the mock paper?
No. See, we are going to open it for 2 hours. But what I suggest is you just have an 2 hours time within these 2 days specifically, and you keep your timers.
Okay,
That would be a better approach. Okay.
okay, sir.
That will give
Sir,
you an
when will the
idea.
result declare?
Result of quiz one.
Result of the last quiz, sir.
Quiz one. It will be declared very soon. See, we yet to receive from TCS, so they have to
Oh,
give us the data. So once it is given, maybe 2 to 3 days we will take to check the correctness,
okay.
and we will just publish the result.
Okay, sir.
Okay. So today we will be discussing the most important topics of weeks 5 and 6. So almost most of the topics are already discussed, but anyway we will go with examples, difficult examples. I have solved few easy examples in general live sessions, so watch it. And today we are going to discuss less theory and more examples, okay, so that you will get an idea of what we are saying in week 5 and week 6. So these are the important topics. Firstly, we will see functions of a continuous random variable. Okay.
Hello, sir.
Uh-huh.
Sorry to interrupt before you start, sir.
Hmm.
I think actually last time also when we discussed the mark questions, no, but the questions were too hard apart from what we discussed in the mock, sir. So I would, we request you to discuss the questions which, as hard as we would get in quiz two, sir, because like we are discussing questions, easy questions in mock, but when we attend in quiz, we feel it's too difficult there. So it would be helpful if you really discuss similar questions as that we would get in quiz two, sir.
Acha. So how many of you feel this?
Sir,
Mock,
yeah, sir.
mock.
Yes, sir. Same thing, sir.
Yes,
It was
sir.
difficult.
Yes, sir.
Oh.
Same thing.
Mock is easy, and mock is
Quiz.
relatively
Yes.
easy, and actual questions when we get.
It was very hard, sir. We feel actually time taken to
Yes, sir.
solve the question. Each
Yes, sir,
question is
that's true.
it's too long, taking too long to complete, and we were like, end of the day, we were coming like we were not able
18
to
questions
complete
is
it.
good. Question were given
Maybe,
for
sir,
60
maybe
minutes.
the reason
Mock
for
is
it is
quite
the
easy
time
and we can do
constraint.
it, but at quiz, I think it's very difficult.
Okay.
E-
So
Each
one
question
reason
is taking.
maybe it is time constraint. So someone said.
Yes, sir. Each question took 15-20 minutes to solve, so
Oh.
it's very difficult to
Yes, sir, the
complete
main
it.
problem was time.
Yes.
Okay.
So
Okay.
even in mock, if you could explain us that kind of questions, it would be really helpful, sir.
Sure. See, anyway, we are going to do a mock session also, right?
Okay, sir.
So before
But
this,
this is
we
a
are going to
revision.
do. This is
Okay.
revision session. Revision
Revision.
sessions will be happening, and also mock sessions will also happen.
Okay, sir.
Okay. So where we solve each and every question from mock. But what we expected is we are giving the same level. That is what we expected. So whatever
But
questions you see
we
in
felt
mock.
too hard, sir.
Questions
Okay.
was a
No,
time
sir.
check. The main problem is that.
Yeah.
Excuse me, sir.
Hmm.
Sir, I just wanted to add that when I was preparing for quiz one, I had a folder link in my drive which was showing me previous quiz papers. So I solved some of those papers, and I found that after solving those papers, the quiz that I attended was moderately easy. I wouldn't say it was completely easy. A few questions was difficult, but the most of the questions I see the pattern was repeating. So I would say.
So Jen, this is your personal experience. Okay, so let us go ahead with the what are the other speakers are saying. Okay, so if a very difficult question may be very easy for some people, so we should go ahead with what the crowd.
Yeah, but let him share his experience also. No, other people are saying. So
Yeah, when I was solving those papers, they were difficult for me as well. It was not like I just saw and the answer
So
popped
I
in my
did not.
head.
I
It was
did not
very
attempt any
difficult for
quiz,
me.
previous quizzes,
But
but I was just following the live sessions, and I found the paper to be quite easy.
So basically, what
Not
we
It
more.
need to
depends
say
on the
about
time,
moderate.
amount of time
It
what we
depends, sir.
discussed.
It depends. Make a
Depends.
voting, sir. Then you will understand that
Yes,
how
sir. That
effective.
will be better thing rather
Yeah.
than asking people personally.
Yeah. So
Yeah,
because
we will float a form and that would be
yes,
better.
sir.
Okay, that
Okay.
would be better.
Okay, we will see. We will see these things and we will discuss these things at the end. Okay, let us focus about today's agenda. Let us complete that quick. Then we can discuss other things, other stuff, and what to do, what not to do, and everything. Sure. Okay. Okay. Then I request everyone to please be on mute and focus. What am I saying? And be in this week 5 and 6 domain. Okay. So don't just go out of this domain. Just be in the domain and connect with me, and please be on mute unless you have any question in this PDF. What am I saying?
So you have saved these notes, right?
I have saved this notes. No.
We had such an accident before, na, sir?
Yeah. I now I just saved it. Okay. So we will start with what are the concepts I am going to cover today, roughly within 2 minutes. So firstly, we will look at the functions of the CDFs of functions of a continuous random variables. Okay. So we will try to find the CDF of functions of a continuous random variable. So we have a general method and we have another theorem which is pretty much useful. If my function is a monotonic function, then I can directly use this theorem and find the CDF of the function of a continuous random variable. And then we will discuss what is the expected value, how to compute the expected value of function of a continuous random variable. Then we will look at what is this discrete continuous joint distribution. So one random variable being discrete and another random variable being continuous. So how they are jointly distributed and how to compute the marginal of continuous random variable. Then we will go and discuss the jointly continuous random variables, which is week 6. So till here it is week 5. And from here it is week 6. So from week 6 we are going to see what if both the random variables are continuous, how they are jointly distributed, and what is the independence between these two continuous random variables, how to compute marginal densities of continuous random variable and conditional densities of a continuous random variable also with examples. Okay. So these are the main concepts that are covered in week 5 and 6. So we will discuss one by one. So how to compute the CDF of a function of continuous random variable. Suppose the x is a continuous random variable with CDF fx and PDF small fx. So capital Fx is a CDF and the PDF is also known small fx. Now there is a function g from R to R. Consider this function, and that function is a random variable. So because it is a function of a random variable, so it will also be a random variable. Let me say it as y. So y is a random variable now, and y has a CDF which is capital Fy, which is defined as like this. We know Fy of y is nothing but probability that y is less than or equals to y. So what I do is I will just replace this y with this g of x. Now what happens, that is that will be equal to probability that g of x is less than or equals to y. So all the x's such that when this g of x is less than or equals to y is what we want, and the probability of those x's. So that is what it is. So all x that satisfy the condition g of x is less than or equals to y. So I have to compute probability that x takes those values, and that will be the CDF of our new random variable y, which is a function of x. So we will look
sir,
at
we
an
have
example.
so we have to add the values of PDF of x at those points
It's
where g
adding
of x
means
is less than equal to.
okay. Here it is continuous, so we will integrate it, or
Yeah, okay.
so adding or integrated. Okay. So we will look at an example now. So x is uniform between 0 to 1. So when I say x is uniform between 0 to 1, this is how it will be. So this is x. and this is fx. So fx is the PDF. So what will be the PDF of uniform distribution? Continuous. This is continuous. It's not discrete 0, 1. It is continuous, closed interval 0 to 1. It can take anywhere.
From
So what
0
will
to
be
1,
fx?
sir, straight line. Fx will be
Fx is
1 by b
1
minus a, sir.
if x belongs to
1,
0 to 1.
yeah, 1 by b minus a. B is
Yes,
1
sir.
and a is
A
0.
is 0. Yes, sir.
So it will be 1.
Yes,
So
sir.
1 when x is in between 0 to 1
1.
and 0 otherwise. So if I draw, this is how it will be. So this is 0, this is 1, and this is the fx value 1.
Sir,
And
this,
the other thing is, yeah.
this graph, sir, at 1 you draw a straight line, vertical line. So is this right?
See, vertical line is like it ends here.
It implies that
So in this,
at 1 so
within
those
within
y
this
values are there,
interval.
right?
No, that is not there. I just
Yeah.
represented it
Yeah.
like that. So here it is ending and here it is ending.
Yes.
Okay. So this is the PDF of a random variable x, which is uniform, which is distributed like uniform 0, 1. Now there is a new function given to us, which is g of x or y is equals to 3x. So now y is also a random variable. Now what I want is fy of y. So this is what I wanted. So fy of y is equals to probability that y is equals to y. So y less than or equals to y. And this is nothing but I just have to replace y with g of x, and g of x is 3x. So it will be probability that 3x is less than or equals to y. And from here, you can see when will 3x be less than or equals to y? For all x that are less than or equals to y by 3. So when x is less than or equals to y by 3, when x is for all x less than or equals to y by 3 implies 3x will be less than or equals to y. So that is g of x is less than or equals to y. So this is the condition, x should be less than or equals to y by 3. So that is this. So probability that x is less than or equals to y by 3 I need. So this is nothing but fx of y by 3. So this is the PDF. Can I compute the CDF also?
By
So what is the
differentiating
CDF of differentiating or integrating?
integrating.
What is the CDF of a random variable which follows uniform 0, 1 or a comma b? Anyone?
X
So
minus A.
less than 0 equals 0.
It is x minus a by b minus a, sir.
Correct. So it will be 0 when x is less than 0, and it is x minus a is 0 here, by b minus a is 1 minus 0 within the interval 0 to 1, and 1 when x is
When x
greater
is more
or
than
equal.
1.
So you see,
Sir,
now
in
our
this case, shouldn't we write this as small f because it's a PDF?
this is CDF.
CDF only when we integrate it is CDF, right?
You integrate this
CDF
small
of
f.
x.
This is CDF.
No, here in this
You integrate this,
tab.
you are going to get this. You will be
written
getting this.
f of x at y by divided by 3. That one.
Here also it is CDF, right? This is less than or equals to.
Okay.
This is
So
CDF
this is
of
also
x.
CDF of x. And where will y by 3 lie? Within the interval 0 to 1?
0 to y by 3.
No, this y by 3.
It will
Between 0 and 1, sir.
It will be
Between
0
0
to
and
1
0 to
only,
1 by
right?
3.
0 to
0 to 1 by 3, 0 to 1. It will lie between 0 to 1 only, right? It won't be greater than 1. Because what is the support of this g of x? What is the support of y?
0 to 3, sir.
0 to 3.
Support of y will be closed interval 0 to 3. So y can take from 0 to 3. So now y by 3 will be from
0.
What is the range of y by 3?
0 to 1.
0 to 1. So what is fx of something when it is in between 0 to 1? It is x only.
Yes, sir.
So capital fx of x is x. So capital fx of y by 3 will be
Y by 3.
Y by 3.
y by 3.
Sir, please write all the concepts, otherwise.
So this is the concept, right? So we see what you have to do is if I have to find the CDF of this random variable y, so the CDF will be probability that this is the definition of CDF, right? Probability
Support
of
is the positive portion, actually.
support is
Positive portion na, of the graph. How can you find the support of y by 3? Actually, I want to know. Elaborate.
Okay. Can you compute the support of y?
No, I am confused.
Okay. What is the support of x?
0 to 3.
Support of x.
0 to 1.
0 to
0 and 1.
So what is support?
0 to
No.
Support
the
is
definition
For
of
all less,
support-
it will be greater than 0. Greater than equal to, yeah.
Portion of the graph, I know it.
fx.
So wherever fx is greater than 0,
Yes.
so all x such that fx is greater than 0. So for which values of x my fx will be greater than 0?
All values
0 to
between
1.
0 and 1.
All
0
values
to 1.
between 0 to 1. Correct. So my support of x will be 0 to 1. Yes or no? You can see the graph also. So where is fx greater than 0? In this interval only, 0 to 1. Below 0 and above 1, it is 0 only.
So it will be open interval in that case, na?
Why open interval? Even I am
Because-
including 0 also inside it, right?
So 0, if
So fx of 0 is 1, right?
okay, yeah.
So it will be closed interval 0 to 1. So once x can take any value between 0 to 1, what values 3x can take?
0 to 3.
0 to 3.
Yes.
So then what will be the support? So if I compute
Sir, I
xy,
think your screen is not being visible, I think. Is it for
No,
me
it's
or
visible.
for everyone?
No, it is visible.
It is visible.
It is visible.
so support of y, how we can compute support of y
That is
wherever
starting at the top.
that is?
So, but we do not know PDF of y. How can we calculate support of y?
Okay. So for that, just draw the graph of y is equals to 3x. So this is x, this is y. And x will take values between 0 to 1. And this is y is equals to 3x. Okay. So what is the corresponding value when x takes value 1? It will be 3. Yes, no.
Yes.
All right.
Yes, sir.
Yes, sir.
Sir,
x
please, can
takes
you explain
value.
once more?
So x takes values between 0 1. Okay. Just draw the graph of y is equal to 3x. So somewhat this is how it will be. It will pass through origin and it will be going like this. Okay. But we require between 0 to 1 only. So when x is in between 0 to 1, all the values are possible. So each and every possible value, if I substitute all these possible values of y, these all are the possible values of y.
Yes, sir.
Yes. So from 0 to 3, all the values are possible for y.
Yes, sir.
Now just forget about support. Y can take values between 0 to 3, correct?
Yes, sir.
Now, what are the values that y by 3 can take then? If y
That
is
can
taking
take
value
0 to 1.
0 to 1. So when it is between 0 to 1, what is fx of x? It is x.
X.
Correct?
Yes, sir.
Yes, sir.
So it will be y by 3. So now what we got, fy of y is y by 3. Where? In which interval?
If y lies between 0 and 3.
So when y is less than 0, it is 0. When y is in between 0 to 3, why it is 3? This is actually this y by 3. Just concentrate here. This y by 3 is when x is in between 0 to 3, 0 to 1. So my y is basically 3x. So just multiply 3 to this inequality. So this will be 0 less than or equals to 3x less than or equals to 3. So this 3x will be y. So from there it will be. From there you can get. So this is 0 less than or equals to y less than 3. It will be y by 3. And 1 when y is greater than or equals to 3. So this is the CDF. So the main idea is, once you wanted to find the CDF of a function of a random variable, to just substitute the whatever you know, the main definition of CDF, then you just replace this y with the function. Then after replacing it, you just have to find the set of all x that satisfies this condition. So that is how you have to find. So set of all x belongs to those x such that g of x, the condition g of x is less than or equals to y, the condition is this condition. So you will get a condition once you substitute y with that function. So the set of all x's which satisfies that condition is what we wanted. So the probability of those set of all x. So this is how you can find like this.
You find PDFs now, sir.
Sir, here we find fx, fy by 3 fx, but we have to find fyy, sir, CDF of function y with respect to y. But here we have find fxy by 3. So both are same, sir.
See, fxy by that is what we got, right?
Yeah.
Fy of y is equal to this, and that is equal to this, and this is equal to this, and this is equal to this. So fy of y is nothing but fx of y by 3, and both are equal to y by 3.
Okay.
So from there we got this. Now y by 3 is 0 less than or equals to y less than 3, 1 when y is greater than or equal to 3. Okay, if you wanted to find the PDF, so just differentiate it. Fy of y will be 1 by 3 when y is in between 0 to 3, and it is 0 otherwise. And this is again, now again y follows. So this PDF is more or less same for like uniform. So y is nothing but it follows uniform 0 3. So you can check, that is the PDF of an uniform.
How do we get PDF, sir?
You just integrate it, no? Sorry, differentiate it. Differentiate this one.
Okay.
Sir, to find the CDF, even we can integrate also, no, sir?
To find CDF, you can integrate PDF.
Between 0 to y by 3?
0 to 3.
0 to 3. 0 to y.
0 to...
So that is what the CDF, right?
Yes, sir. Less than.
See.
Sir, I have one doubt. Like, it's there's something if you can comment on that. So
one second.
Yeah.
Okay, y is less than or equals to y.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So you will get.
Yes,
You can check.
Yeah, I got it.
Both your
Thank
side.
you. Thank you, sir.
Sir.
Yeah. Just.
Yeah. So suppose like in discrete random variables, we like if there is a function of x. Suppose we have a discrete random variable and we know its PMF, and then we have its function. So if I know at x equal to 0, this is the probability. This is its PMF. And then I have a function. So I put that value in that and I get the same PMF for that. So that kind of relationship, why is it not working here?
Acha, whatever we are doing for discrete, why it is not working here?
Yeah, it should at all those values where x is taking all, suppose where y is taking that value, all those x are used to add probabilities of, right? Is that working here or not? Like, is it totally different approach or they are related in some way? It should work, na sir. Relationship, by definition, it should work. Like it's just the continuity. At the place of summation, there should come integration at most. So can you relate that?
Yeah. I got that. Okay. So one thing is, there you see, if I have a discrete, okay, even then, see, even in discrete case also, it will not work for all such cases, right? All the possible.
No, sir. If it is 1-to-1, sir, then directly it can work. But if it is many-to-one, then we can add some values.
It will get added, right?
Yeah. So that's what I'm saying. At the place of addition, they should come integration at most, right? That's what I'm saying. So
see, that is what the theorem says. The next theorem is what is going to come. That is what it will be, right? When it is monotonic or 1-to-1, I can just map. I can just translate, or I can just scale, or I can just affine. There are three things.
When
right?
it is
when it is 1-to-1. When it is 1-to-1. So whatever you said in discrete case also, you are just mapping 1-to-1, right? 1-to-1, and you are saying that the same PMF I am going to get.
Yes.
Right? Here also, that theorem states that if it is monotonic or 1-to-1, what you are saying, the PDF or the CDF, the PDF actually, the PDF will either scale or translate, or it will affine. Affine means it's the combination of scaling and translation.
Okay. Got it.
You don't need to worry about again how to compute, or you don't need to use this traditional general method.
Okay.
So yeah, that is how you can relate. If it is 1-to-1, the next theorem will going to work.
And this general method will work for discrete random variables also, right? Okay.
It will work. Yeah. So that is why it is general. It is not called as general method, but most of the people will use this method. Each and every problem can be solved using this method itself. Okay. Yeah. So just try to solve this then. Let me check. I'm just giving it now. So let me take it is uniform between 0 to 1 only. And my g of x is, I hope this is what I have given later. So gx is 3x plus 5. So what I want is, so let me say this is y. I want fy of y.
Hello.
Any quick answers?
So can we move ahead to the topic?
Ahead. I just asked the question here.
Y minus 5 by 3 from 0 to 8, sir. Something like that.
Y minus 5 by
3 between
When y is between 0
to 8.
0 to 8 or...
Hello. Do you want to hear me?
3, 7, I is less than 5.
5 to 8, sir.
5 to 8, sir. 5 to 8.
Okay. 5 to 8.
And when it is less than 5, it is 0, sir.
Okay.
And when it is greater than equal to 8, it is 1.
So, did everyone got this? Those who have solved.
Yes, sir.
Yes? Yeah. So, very simple. Those who haven't
Hello.
done...
Do you able to hear me?
Yeah. Now I can able to hear you.
Yeah, sir. What will be the, in the previous example, if I say it is y equal to minus 3x, then what shall be the answer?
Y is minus 3x.
So there is no support for, yeah.
Okay, we can do that also, right? So y is given to be minus 3x. So now what you have to do? So from here, what happens is, when will minus 3x be less than or equals to y?
When x greater than or equal to y
X
by
is
3.
greater than equal to minus y by 3.
Minus y by 3.
So when x is greater than or equals to minus y by 3. Okay. So now what is this?
1 minus fx of minus y by 3.
So now see, x will be going from 0 to 1. X is in between 0 to 1. Then where will this minus 3x be? So what will be the set of values of y can take?
Minus 3 to 0.
Correct. Minus 3 to 0. So when it takes minus 3 to 0, minus y by 3 will be in between 0 to 1. Correct?
Yes, sir.
Yes, sir.
And again it will be minus y by 3 only. So we know that when it is in 0 to 1, fx of x will be x only. So then it will be 1 plus y by 3. Okay, 1 plus y by 3 when y is in the interval minus 3 to 0. When y is less than minus 3, it is 0. 1 plus y by 3 when it is in between minus 3 to 0. And 1 when y is greater than what, 0. Greater than or equals to 0. So this is how it will be.
Sir, cannot understand about 1 plus 1 y by 3. How can you deduce?
How did we get that y will lie between 0 and 1? Y by 3. Minus y by 3 will lie between 0 and 1.
See, what are the possible values of y, the small y? It is from minus 3 to 0.
Yes.
Okay. So
from
okay. Then
from there, see, minus of it will be between 0 to 1.
Okay.
So from there, see, this is just simple, right? Just now we have seen fx of capital Fx of x will be x when it is in between 0 to 1. So the same thing we have done.
Yes, sir.
Fx of minus y by 3 will be minus y by 3 only, because this minus y by 3 will be in between 0 to 1.
Sir, minus 1 y by 3 is converted into 1 plus y by 3, na?
This minus and minus, na? So here there is minus and here also there is minus. So minus
Sir,
and minus.
I have little bit confusion, sir.
Yes, sir. I agree.
fx of minus y by 3 is 0 when minus y by 3 is less than 0, right, sir?
Minus y by 3 is less than.
Okay, so that turns into greater than equal to 0. Okay.
That will turn into greater than or equal to 0.
Yes.
Okay. So it will be 0 when y is less than minus 3, 1 plus y by 3 when it is in between minus 3 to 0, and it is 1 when y is greater than or equal to 0. So if the question is y is minus 3x, okay, if our function is like that. So just the same traditional method we are using. There are 3 steps involved in this. So firstly, write the definition of CDF, then substitute, just remove that new random variable and just substitute it the function, and look at or convert this given condition in terms of x. So just put x on one side and look at the other term on the other side, and then try to write that probability in terms of fx, capital Fx. So that is all what you have to do. So 3 steps. So within these, if you follow these 3 steps, you can solve any problem in this. Okay. So this is also the same thing. Once you solve it, try to solve. Those who haven't solved it, try to solve it. So try to put these things. So this is 3x plus 5 less than or equals to y. So from here, just try to bring x something and try to write in terms of fx. You will get the answer. You will get this.
So it's PDF will be 1 by 3 when between 5 and 8.
PDF will be
1 by 3.
1 by 3. Yeah. 1 by 3 only.
Okay.
Okay. So then there is another theorem. When I know this function is monotonic also. Monotonic means either it is strictly decreasing or strictly increasing functions, like straight lines and cubic x cube. So x cube is an increasing graph. So like this, x square only on the positive side. So these all are increasing functions. So this is an increasing function. X cube is an increasing function, or straight line is an increasing function. This straight line or the other slope with negative slopes are also, these are decreasing functions. So these are called monotonic functions. So either it is strictly decreasing or strictly increasing. So strictly increasing or strictly decreasing. So if I know whatever the function we are,
Second one is not monotonic.
This one.
Yeah. Yes, sir. The second graph plotted.
Why?
Because it is not strictly increasing or decreasing. It is both.
It is.
It is both.
It is no. Why not?
Because it is increasing as well as decreasing also.
Where it is decreasing?
So on the left side.
It's increasing throughout.
This one.
As the value
of x increases, and if it if it increases, then we say it increases, and if it decreases, then we say it decreases. You can't go back on the x-axis.
If you go move towards the left, right, in negative value, -1, -2, -3, the value of x decreases. So the value of y again decreases. So it is decreasing only.
No. See, this is between x and y, okay? How do we check increasing and decreasing is by looking at x and y, between x and y. If I increase x, if my y value increases, then it is increasing. If I decrease x, my y value decreases, then also it is increasing. But if I increase my x, if my y value is decreasing, or if I decrease my x, if my y value is increasing, in these two cases we say it is decreasing. The graph is decreasing. That means as long as I take larger and larger values of x, my function value will become lower and lower or lesser and lesser. So if there is an opposite sign between y and x, if they are negatively negatively connected, then those kind of functions are decreasing. So in this case, you see at -3 or -2. So x is -3 and x is -2. You just take two values. So if I move from -3 to -2, that means I am increasing my x value. So I'm slowly increasing my x value. Then look at the corresponding y values. So -3, the corresponding y value will be somewhat here, but for -2 it is greater than -3. So even y value also increases. So if I increase x, if my y value increases, that is increasing function. So the same thing holds here also. So it is an increasing function. So from graph perspective, if you wanted to see, if the graphs are going from down to top, they are increasing functions. So somewhat like this, or like this. So these all are increasing functions.
Will be the mirror image of this.
Mirror image with respect to y.
Yes, sir, with respect to y axis.
With respect to y, if you look at the mirror images, they will be decreasing functions. Okay, so this will go from bottom to top. So your graph will start from somewhere from bottom and it will go to the top. They are increasing. If you see the decreasing, it will start from top to bottom. This is top to bottom, from left to right. So I am saying from left to right. If you see, if I move from left to right on the graph, I should go from bottom to top for increasing. If you want a bit clarity, you just go back and watch the videos from Max 1. So there we have discussed a lot regarding this strictly increasing, strictly decreasing. So the main idea is it should be strictly increasing or strictly decreasing. Which should be strictly increasing? Whatever the function we have seen just now. So this g of x. So I have a random variable x, which is a continuous random variable with PDF fx, and also whatever the g of x, my function g of x, I am letting it to be monotonic within the interval, within the support of x. Okay, it is enough within the support of x because we don't need to worry about outside of the support of x, because there the PDF is anyway 0. If you integrate it also, it will be 0. So we are more interested in the support of x, or the interval in which x can take values. So that is known as the support of x. So within that interval, if my g of x is monotonic, I am letting it to be monotonic, and also this g of x is a differentiable function. So when I say differentiable function, it will have a derivative. It will have a derivative.
So
then
can we say that support of x is equal to the range of x?
See, you can correlate. If it is discrete, we say it is range. If it is continuous, we say it has support. So that's the wording.
Okay, sir.
Okay, you can treat it like that.
I always found support to be very confusing. That's why.
No. So, but make sure at the boundaries, okay? In the interval boundary points, just make sure there your PDF shouldn't be 0.
Okay, sir.
Okay. So if it is 0, you have to exclude the boundaries. So then the closed interval will become an open interval. So that is the only thing you have to check.
So at the boundary, it shouldn't be 0, right?
At the boundary shouldn't be 0, that we cannot say, right? Sometimes it may be 0 also.
Oh, okay.
So x can take that value with 0 density is what we give sometimes, but it shouldn't be given. But sometimes it will be like something like this. So some cx when x is between 0 to 1 closed. So when I take x is equal,
we have to remain conscious at the boundary points.
So you have to be very conscious about this 0 and 1. So when I substitute 0, my density, so if I say this is the density function.
Yes, sir.
So if I substitute 0, my density will become 0. So whatever the value of C may be, C times 0 will be 0.
Okay.
So then this 0 will not be coming into the support, because support of X is defined like wherever the density is greater than 0, strictly greater than 0.
Okay,
Correct?
sir. Yes, sir.
So this is boundary points. You should be very careful. Just check for boundary points, and other things will be pretty similar to range.
Okay, sir.
Okay. Yeah. So and
Hello,
also
sir.
derivative is
Sorry to interrupt. Sir, actually, I saw a similar problem when I did the extra activity 5. So can I ask the question at the last, or can I ask now, sir? Because it's related to data actually. I try to
maybe at the end.
map the uniform distribution. Okay, sir. I'll ask at the end, sir.
And
The same uniform distribution only. Okay, sir.
Okay. So we will see it at the end. Okay.
Okay, sir. Okay, thank you.
Okay. Yeah. So two things we are letting. First thing is it is being monotonic, and also it is having a derivative which is g dash of x, which is dg of x by dx. So if it is satisfying these two conditions, if my g of x is satisfying these two conditions, then I can directly write my PDF of y, which is equals to g of x, as fy of y, which is equals to 1 by mod g dash of g inverse of y times fx of g inverse of y. This is the formula. Okay. And I asked in the previous session also, in week 5 solve with the session, how many of you tried to prove this?
I did, sir.
Did you get it?
Yes, sir. Yes, sir.
That's right. Yeah. So which method you followed?
So general method only. Is there any other?
No, the same thing. From the general method only you can get it. Okay. Yeah, but this is the formula, you can directly use it. If it is monotonic and if it has a derivative with which is g dash of x, then I can directly use this formula. And if you remember this formula, it's okay, well and good. In quiz 2, I don't think we are going to give this formula to you. I have to check with this. If we have to give, then we will give you definitely. Okay, you don't need to by heart the formulas or anything.
So then
make
give
sure
it. Then give it, sir. Then give it.
Okay. Okay. Okay.
Sir,
but
after
about
some
this
time
formula
we'll
only,
just
sir.
After
About
some time
this
we'll forget it.
About this formula only, sir. If you compare it with like a discrete random case, then fy of y was equal to fx of g inverse y, right? This denominator term was not there. Right. So I'm able to drive it, but like correlate, I'm not able to. Why this extra term is coming here? In discrete random case, if you find the PMF of y at a specific value, you will just like go to x if it is monotonic and say whatever is its PMF, the same one is for it, right? And now you're dividing by a number, so I do not get what is this? Why this extra term?
What is this extra term actually? What is the g dash of g inverse of y?
So this is the rate of change of x with at that point.
Rate of change of
x with this.
No. When you try to prove this, you will get it. When we will start with this, right? Are you starting with this?
Yes, sir. Probability of y less than equal to y. And then probability equal to g of x less than equal to
from
y.
Here.
And then we can say x less than g inverse of y. That is yes, fx of g inverse.
This is capital F.
Yeah. This is CDF.
CDF. In order to get PDF, we are going to differentiate it.
Yes, sir.
Correct. So if I differentiate the right term, the left side term, if I differentiate, you are going to get directly Fy of y.
No, sir. In the formula, I'm getting where this term is coming from. Like in the derivation, I get where this term is coming from. Theoretically, I do not understand why this term is in continuous random variables and not in discrete random variables. For them, the numerator terms are equal. And here it is different. So what is it that makes this different theoretically?
Okay, maybe see, that is what this scale, translation and scaling will matter, right? It will change the support or the range of or that is what the support of this y and that x will either be scaled or enlarged. When it is being enlarged, then what happens is within 0 to 1 you will have some density, but once it is enlarged to 0 to 3 or 0 to 5,
it has to be divided.
Then the density will be divided. Will get divided automatically.
So basically the reason is that for PMX is for points, so there is no that and here density is for like length, so it has to be divided by due to the transformation.
Transformation or the scaling.
Okay. Thanks.
Just use this formula and try to find this. So the same example, g of x. Others, have you done?
So you're only trying to understand this formula, not try deriving.
Okay. See, from here it is very simple. If I differentiate this, what happens is, so you know this, right? If I differentiate, I'm going to get fx of g inverse of y, and then this g inverse of y should also be differentiated.
Yes.
Yes.
Okay. This will be something like g dash of g inverse of y f x of g inverse of y.
Yeah.
Just a second. Okay. So how do I get this into denominator? Okay. So see, this is with respect to
if you're writing dy by dx from then
this is with respect to x, we are derivating it. So this is not z dash. This will be
d by dx
of d g inverse of y by d dx.
Yes.
Now what I will do is d g inverse of y divided by dy into dy by dx. Now inverse of y, and here dy by dx is d dash of x, g dash of x. I'm missing some manipulation. We have to do some manipulation here. D by dx, dx by dy. Okay. See this thing. Observe this thing. G dash of x is dgx by dx. If I just put in place of x, if I just put g inverse of x, g dash
G inverse of y, sir.
G
Inverse of y.
G inverse of y.
Yes, sir.
I am going to get d g
G
of
inverse of
g inverse of y by
yes,
dx. So this will be dy by dx. So this is g of g inverse of y will be y. So dy by dx is g dash of g inverse of y. So I have to get dy by dx.
And it's in absolute terms, no? Mod.
We make it absolute because fy of y shouldn't be negative.
Okay.
So for removing that negativeness, we will take the absolute thing. And I should get dy by dx and write it as g dash of g inverse of y. There's something to go to. Dx by dg inverse of array. Okay, so here also it will be right. In place of x, I am substituting g inverse of y. So then it will be dg. In place of x, it is g inverse of y. In place of x, it will be g inverse of y. So this is dy by dg inverse of y. Dy by this thing, I got it as g dash g inverse of y. Okay, dx by dy. What about dx by dy? One by g dash of x. Okay, I just don't want to waste the time. I'm missing something. We have to some manipulation. Something I have to change it here. We will be getting that 1 by mod g dash of g inverse of y. So maybe in the next class I will just go back and just try to solve this, and I will just come back. But as of now, believe me, this works. This can be proved. So this is something I am missing here. So if I just substitute that, I am going to get that denominator. So as of now, believe me and use this formula and try to solve this. Firstly, you have to get these things first. What is g inverse of y? What is g dash of something? Okay, then I can get combiningly. I can get g dash of g inverse of y, and I can just directly substitute this in this. So what will be g inverse of y for this?
Y by
3.
Yeah, y by 3, sir. Y by 3.
See, g inverse of x is x by 3. So g inverse of y will be y by 3. And what will be the g dash of something? So if g of x is
3x.
What will be g dash of x?
3, sir.
So g dash of x is 3. See, it is independent of x. Whatever the g dash is, whatever the x is, my derivative will always be 3. So this implies that g dash of g inverse of y, which is g dash of y by 3. So even though it is x,
sorry, g dash of 3x will be 3, no sir. G dash of x will be 1.
When g of x is, so when g of x
G
is
prime
3x,
we are talking. It's g dash is nothing but derivative, right?
Derivative dgx by dx. So what will be d
Now it will be
gx
3.
3?
So 3.
So g
So
dash
G-
of y by 3.
Oh, okay.
Yeah.
G dash of gx, not g dash of x, no? Sorry, if
G dash of x only, right?
g dash of x is just derivative of x. G dash of
Yeah.
maybe I'm missing something. I'll check, sir.
G dash of x is derivative of g of x.
Oh, is it?
Yeah.
Okay.
Yes.
So how did you get g inverse of y as y by 3?
So, sir, can you go step by step, sir? Go
Okay.
step by. Okay. So I know, sir, it is very basic, but somehow I always go do the mistake.
Okay. So in order to find inverse, first of all, we will try to find the inverse. In order to find the inverse, we wanted g inverse of x. So for that, what we have to do is you just take g of x as y and let y is equals to 3x. Then what you have to do is write x in terms of y. Okay, so this is y in terms of x. Now what you have to do is you have to write x in terms of y. So how can I write x in terms of y? X can be written as y by 3.
Yes.
Yes, sir.
Then just simply replace x with g inverse of x. So here replace, sorry, x with g inverse of y.
Oh, okay, sir. Got
Okay.
it.
So once just replace it. G inverse of y will be y.
Okay. Okay. This is clear. Now on the.
Now once you get g inverse of y, the next thing is you have to find g dash of x or g dash of y. Okay. So I am interested to find g dash of y. So
But
for
it
that,
is saying, sir, it is saying that it is a g dash of g inverse y.
that for that you should get first at least this thing, right? What is g dash of y or what is g dash of x?
Okay.
So when g of x is 3x, if I differentiate it with respect to x,
So it will be 3.
so it will be 3. So you see g dash of x is 3. If I replace x with any other value, it will be 3. Correct? It is independent of x. The derivative is independent of x. So even though I substitute g dash of g inverse of y, it will be 3 only. In this particular example.
So then, like, is it still necessary to find g inverse of y? Because
See, sometimes you don't know, right? What if g dash of x is something 3x or 3 by x something? Then g inverse of y is important.
Okay.
In the next example, we will get to know.
So in this question, we will leave like this, sir, because I'm stuck only in this step.
In this question, what happens is g dash of x is going to come out to be a constant.
Yeah, constant.
And it is independent of x. Okay. If
Okay.
it is g dash of x or g dash of g inverse of y or g dash of y by 3. So we know g inverse of y is y by 3. So what is g dash of y by 3?
So
It is 3 into 1 by 3, sir.
3 into?
No, it's 1 by 3. Actually, if you differentiate
1, sir.
1 by
1 by 3, no, sir, because if we
g dash of y by 3 is equal to 1 by 3.
Okay. So x and y you are getting confused.
No. It will be constant.
Whatever the value may be, it's constant.
So isn't it 3?
It will be 3 only. So g
Yes,
dash
3
of
only.
y. So if my g of y, I am taking as 3y. So what will be g dash of y? 3.
3.
So this is independent of y. This 3 is independent of y. Even
Yes,
though I
sir.
put y or y by 3 or y by 2 or 2 or 1 or 4, any value, I am going to get my derivative to be equal to 3.
3. Yes,
So
clearly.
even though g dash of y by 3 will also be 3.
Yes, correct.
So nothing,
Yes,
whatever
sir.
the inside
whatever
part,
the value of y. Okay, sir.
whatever the value of y is, you don't worry, the derivative value is 3.
3.
So
Okay,
this
sir.
y by 3 is nothing, but in this case it happened to be g dash of G inverse of y, it happened to be equal to 3.
3.
So it is independent of G inverse of y.
Sir, one question, sir. Maybe very basic question I am asking. So by mistake, if I put gy equal to 3y, and in the gy I put the g of g inverse y values, and then do the derivative, it's a wrong one. Again, I am saying in the gy equal to 3y, in gy in position of y, I put the y by 3.
Okay, y, you just put the y by 3.
Yeah, okay. So
it will be y.
Then g dash g, then I make the derivative.
Then
sir, it will be 3, no, sir.
Once you make the derivative, what happens? G dash of y by 3 into derivative of y by 3, which is 1 by 3. And this will be 1. And
Sir,
from
g
here
of
also,
y by 3 will it be 1, no, sir?
Correct. Yeah.
Okay.
Okay. Thank you, sir.
See, even if it is y or y by 3, it doesn't matter. It will always be constant. Derivative is always constant here.
Yes.
We got to be constant. Okay.
Yes, sir.
Then the inside one is y or y by 3 or y minus 1 or y by 2. It doesn't change. The derivative is always 3.
Yes, sir, but by the process, if we go first, we will find the g derivative, right? And then we will put that value inside instead of x. Right?
Okay. See, whatever method you approach, ultimately you will get the answer to be same or the correct. Okay, even this method or this method or that method, everywhere you are going to get 3 only. See, understand
so the
this.
final answer will be y by 3, sir?
Final answer will be, see, here itself you can see. This value we got it as 3.
3, 1 by 3.
Fy of y is 1 by 3 into this g inverse of y is y by 3.
Y by 3. Yes,
so fx of y by 3. Okay. So from here, what are we going to get?
Y by 9. Sir. Just we have to multiply also.
Y by 9.
Yeah, this is the problem. I get y by 9.
It's not y by 9. Fx of y by 3. What is fx of y by 3?
It will be y by 3 only.
It will be,
because the value is the fx of x is equal to x here.
No. Here small f.
This is 1, no, sir.
This is PDF.
Yes, sir.
Oh, this is PDF. Yeah.
Fx of y by 3 will be 1 because it will be uniform
in 0, 1.
Uniform between 0, 1 and 0
correct,
otherwise.
Sir. Correct, sir. Yes,
okay,
correct,
this
sir.
will be 1 by 3 into 1. So we are going to get Fy of y as 1 by 3. So the PDF is 1 by 3. So it will follow uniform. If you integrate this, you will be getting y by 3, which we got in the above also.
That's what I got y by 3. Okay, sir.
So don't confuse with the CDF and PDFs.
Yes, sir.
Okay. This is, see, you will do all the thing and a small confusion will lead to the wrong answer.
0 marks.
How we calculated here y by 3 once that part?
Y by 3, see, we know the PDF of fx, okay? So when x is in between uniform 0, 1, what is the PDF of x?
So we calculate in previous step, right? So,
this is uniform, right? 1 by b minus a, and it will be 0, 1 in when it is in between 0 to 1 and 0 otherwise. Okay. Here you see fx of y by 3 will come and lie in the interval 0 to 1 because y by 3 will be in the interval 0 to 1 only. So when it is in the interval 0 to 1, it will be 1. Okay. So either this value will take 1 or 0. and it will take 1 when x is in between 0 to 1, and it will take 0 otherwise. Similarly here also, fy of y will be 1 by 3 in the interval 0 to 3, and it will take 0 in all other intervals.
So there, sir, in fx y by 3, we are putting the PDF value, right? Not the CDF value.
Not the CDF. See, small f. This is regarding the small f. PDF. Okay.
So just one more doubt, sir. In PDF, we will be integrating, right? And CDF, we will use just the formula of like FB minus FA, right?
Correct. So if you integrate PDF, we are going to get CDF. If you differentiate CDF, we are going to get PDF. Again, don't confuse with I have to integrate a CDF, I will get PDF, or I have to differentiate PDF to get CDF. So CDF, treat it like this. CDF is superior to PDF. So if I have to go to PDF, I have to integrate. Okay.
Differentiate, sir.
No, CDF. Sorry.
Differentiate.
If I have to go to CDF, I have to integrate my PDF. So CDF is superior to PDF. Okay. Integrate PDF. So like this, CDF and PDF. So if I have to go to top, I have to integrate. If I differentiate, I will get this.
Yeah. Yes.
Okay. So CDF differentiate, we will come to PDF. I will get PDF. If I integrate in PDF, I will go to CDF. Okay. So solve
Sir,
this also.
please explain the last line.
Which one?
G inverse of y by 3 into 1 by 3 equal to this line. I understand that G inverse of y by 3 is equal to 3. All time it is constant. Then
I didn't get. G inverse of y is y by 3.
G inverse, not derivative of g y by 3 equal to 3. All time it is 3 constant. Then g derivative g inverse of y equal to 3. Okay. Then after the last line.
After that, just substitute, na? Just substitute everything. I know that g inverse of y is y by 3, and this value is 3. Just substitute here. This is 3, and this is fx of y by 3. G inverse of y is y by 3, and this fx is uniformly distributed. So even here also.
How can you calculate fx g inverse of y? Please explain.
Fx of y by 3. So fx will take either value 1 or 0. Okay. Fx of y by 3 will take value 1 if this y by 3 is lying in between 0 to 1. And it will take 0 if this y by 3 is lying anywhere outside or otherwise. Okay.
Now, which value I should put? 0 or 1?
See, when y by 3 is in between 0 to 1,
yes,
I will put
it
1.
Is 1.
Okay. So that means when y is in between 0 to 3, it is 1, and my density value will be fy of y will be 1 by 3 times 1 if y is in between 0 to 3. Okay, you are giving your value as 1 here now, and 0 otherwise when y is taking other value.
Not in the range. Okay, y is not in the range, then it is 0.
Then it will be 1 by 3 times 0. So this will become 0 then. Okay. So you solve this. First of all, find what is fx of x. Then find g inverse of y. Then find g dash of g inverse of y. Then just substitute.
Sir, I got the answer 1 by 15. It is coming. I don't know it is correct or wrong.
Yes, sir. It is 1 by 15.
It's 1 by 15, is it?
Yeah.
So fx of g inverse of y. So firstly, what is fx of x?
It will be 1 by 5.
Yeah, 1 by 5 when x is in between
-3 to 2.
0 otherwise. Now tell me what is g inverse of y?
Y minus 3, y minus 5 by 3.
Correct.
Okay. Y minus 5 by 3. Everyone agree?
Yes. Yes.
Now you see g inverse of this is okay. What is g dash of x?
3.
3.
3 again. Okay. If g dash of x is 3, if I just replace x with g inverse of y, will this right side value change?
No, sir.
No. So this
No,
is
sir.
nothing. This is also equal to 3.
Yeah.
So now just substitute the values. Just substitute 3 in place of this. We are going to get 1 by 3
into 1 by
this
5.
is fx of g inverse of y. What is g inverse of y? Y minus
Y
5
by
by 3.
Yeah.
Okay. So this is 1 by 5 if it is in the interval -3 to 2. So now I have two things. So this fx of y minus 5 by 3 will be 1 by 5 if -3 less than or equals to y minus 5 by 3 less than or equals to 2.
Can you
Or it
please mute others?
Yeah. Please be on mute, no? And then, yeah. And this will be, this fx of y minus 5 by 3 will be 0 if it is in between, otherwise. Okay. So just simplify this. We are going to get -9.
-4, 11, sir.
-4 to 11.
Yes, sir.
Sir, if I want to, sir, calculate the CDF now from this equation, so what should be the limit now? Limit will be tricky one, I think.
Limits we will compute. We will compute the CDF also.
Okay. Thank you, sir.
Okay. So this is, if I simplify this, I am going to get -4 to 11.
Yes, sir.
Okay. So that means my my PDF will be 1 by 15 in the interval -4 to 11, and it will be 0 otherwise. And what type of PDF is this? Uniform?
Uniform.
Yes, sir. Uniform.
So you see this 1 by 15.
So did you go through this just now? If g dash of x is not equal to a constant.
Not equals to constant, I guess. No, yet not.
Okay, sir. So it's coming, right?
I will take it.
Okay, sir.
Okay. So this is 1 by b minus a. Okay. B and a are -4 and 11. So y is uniform between -4 and 11. Okay. So now if I wanted to compute the CDF of this, I just wanted to compute the CDF. I know I got the PDF. Sorry, y of y as 1 by 15 when it is in the interval -4 to 11 and 0 otherwise. So I wanted to compute the PDF. Sorry, CDF.
Yes, sir.
It is probability that y is less than or equals to y. So this is y is in between
0.
-4
to 11.
Sir,
to 11.
So can we also see it as like our function was 3x plus 5, right? So our interval was earlier -3 to 2, so it has been multiplied 3 times. So earlier length was 5, and now it 1 by 5. Now it will become 1 by 15, right?
Correct.
and also it has been transformed, like 5 steps it has been moved right side.
Right side.
Right, we can see it like that, right?
Correct. You can see it like that. So now I have to find this probability. In order to find this probability, I know that I have to integrate it from -4 to y, fy of y dy. So I know fy of y in the interval -4 to y. So I am integrating from -4 to y because less than -4 it is 0. No need to integrate. You can just look at the support itself. This is 1/15 dy. And we are going to get y/15 and the limits are y and -4. And it will be y/15 minus -4/15. And we are going to get y plus 4/15. Okay.
So very well
This is the
explained,
schema.
sir. Very well explained. Very well explained.
Okay. So let's take
It's
an
uniform.
example.
We can do that y minus a upon b minus a also, no sir?
You can do that also. If you know it is uniform, you can directly do that. Okay, now I will just take an example where it is monotonic, but my g dash of g inverse of x will vary according to value of x. So look at this. So let me say x is uniform between 0 to 2. Okay, and I'm going to take my y, which is g of x, as x square. Okay, now I have taken it as x square. So x square in the interval 0 to 2 is monotonic. If I draw a graph also, it will be like this. So it is strictly increasing. So no issues. It is monotonic and also it has derivative and everything. I just wanted to find fy of y, then we can compute CDF also. Okay. So what is fy of y? So the same steps. Step 1, just write fx of x first of all. Then compute g inverse of x. And then compute g dash of g inverse of y. Okay, g inverse of y, compute g inverse of y. Then compute g dash g inverse of y. Then finally, just put it everything here. Okay, go step by step. Just write this first. So this is very easy, I guess. What is fx of x?
1/2.
1/2.
0 to 2.
And it will
0
be
otherwise.
Now find what is g inverse of y in the interval 0 to 2.
Root y, sir.
Root y, correct. So it will be square root y. So how do I, what I said, I just said, just let y is equal to x square. Then write x in terms of y. X I can write it as root y, or x I can write it as minus root y. But you see we are in the interval 0 to 2. So if I square root it, my x values will always be positive, should come to be positive. But if I let x is equal to minus root y, these will go into negative values because square root of y is positive. So this case we will ignore. So x will be root y. So just substitute in place of x, just substitute g inverse of y. So g inverse of y will be root y.
Sir,
so that
is
is
it 1/4 root y?
1/4 root y is
Yes,
g dash of g inverse of.
No, sir. Last, the final one.
Final
Yes.
one. We will go and check.
Okay.
We will just go one by one.
Yes, sir.
Now you see g inverse of y is root y. So
Yes,
what
sir.
is g dash of x? So in order to compute this, we have to compute first of all what is g dash of x.
2x.
2x. Now you see g dash of x is 2x, Then what will be g dash of g inverse of y?
2 into g inverse of y.
Yeah, 2 into g inverse of y. Just replace x with g inverse of y. That's it.
Yes, sir. Yes, sir.
Now 2 times g inverse of y. So g inverse of y I know. G inverse of y is root y. So it will be 2 times root y. So it will be 2 root y.
Sir, how come G inverse X is 2x?
G inverse G dash.
X.
This is G dash.
Yes, sir. G dash of X as 2x.
See, G of X is x square, right?
Yes, sir. Okay.
Just derivate it. Just derivation of x square is 2x.
Yeah. Okay.
Yeah. So this is 2 root y. Now just substitute. So 1 by 2 root y into fx of g inverse of y is root y. Now this I can write it as this is 1 by 2 root y into first step we have written. So fx of x is half when x is in between 0 to 2. Okay. So this is half when root y is in between 0 to 2. And it will be 0. Fx of root y will be 0. That means 1 by 2 root y into 0 will be 0 otherwise. So if I simplify this, I am going to get this value as 1 by 4 root y.
Yes, sir.
In the interval 0 to 4. Okay. So this is the PDF.
Sir, I have one doubt, sir.
Hmm.
Sir, one basic doubt, sir. I understand the step number 2, 3, and 4, but I have doubt in step number 1.
1? Okay.
Yes. Actually, if x is equal to from the distribution uniform 0 to 2, you directly just put the value as if x of x is equal to half.
It is actually 1 by b minus a, right? So when x is in between uniform AB,
actually I
then
forgot
we know
the formula.
We will give the formulas, don't worry. You just have to go and check. So this will be 1 by b minus a when x is in between a to b.
2 minus 0 equal to
2 minus 0 it will be. So it is basically the length of the interval. B minus a is the length of the interval.
Yes, sir.
Yeah. So this is how we can solve. Okay. Let's move forward. We will just see quickly what are these expectations. So expectation is basically the same thing. Expectation of g of x. If I wanted to find the expectation of g of x, I have to integrate it from minus infinite to infinite wherever the integral exists. So it's not from minus infinite to infinite. Basically, you have to integrate along the support of g of x, basically. So wherever g of x is defined or exists, in that integral, you have to integrate it with g of x times fx of x dx. So the same thing, even in the where we have done this.
In the discrete random variables.
While we do the summation, we replace x with the g of x, function of the random variable, right? The same thing here also. Just replace x with, so normal expectation. So if I have to find the expected value of x, expectation of x, so I will just integrate it from minus infinite to infinite, x into fx of x dx. So just replace x with g of x. That's it. So the expectation of expected value.
One doubt, sir. So if I take y equal to g of x, right? And then I say expected value of y. So that will be, if you can write that, minus infinity to infinity, y fy of y dy, right?
Fy of y?
If I take y equal to g of x.
Okay, if you, even though you take y is equals to g of x, it is actually a function of x, right?
Yeah. So if I try to write expected value of y, as you wrote expected value of x above.
Okay, expected value of y, integral minus infinite to infinite, y
fy of y.
No, it is fx of x only. So even this y is actually a function of x. Even this will come to be in terms of x only.
But so we can write that na fy of y if we want to, because it's the PDF y. By definition, we can do that, right?
Fy
Y
of
is a
y,
random
you are
variable,
writing.
so we can do that.
So you wanted to write fy of y.
Yes, sir.
Dy.
Yes. So now I want to know how they are equal. I understand y is equal to g of x. That I'm good with. Fy of y, how does it becomes equal to fx of x? For discrete random variables, we know that it is equal, as we talked earlier, right? But
No,
for
I'm not
continuous,
sure
how is
about
it
this.
equal? Why are we replacing the PDF of one random variable with the other, just as it is?
No, are we? I don't think this works. I can contradict this.
I'm saying, like, if you just take y as its own random variable, then you will use this formula, na, y
Okay.
into fy of y into dy, right?
Acha. Okay.
And now y is related to y is also a function of x. Then you will you are saying I will use this formula. So I'm saying they should be equivalent of each other. So what you are doing is you are replacing fy of y with fx of x. But you cannot do that. We did so much hard work, sir, to find fy of y from fx of x. And now you are just replacing it as it is. That does not sound like logical. So why are we able to do it?
What you are proposing that instead of
So there is some TV noise coming from someone's mic, like
not from my end.
Someone can please turn it off. Yeah, it's thank you, whoever it was.
Okay. What can be the possible thing, expected value of y times fy of y?
Y is easily replaceable by g of x. That is clear, sir, right? But fy of y, it should not be replaced by like PDF of x. It is saying that PDF of x is equivalent of PDF of y, but that is not the case, right?
No, it's not saying that.
Maybe there's dy and dx also. Maybe that can make some difference.
Okay. Can I come back some other time? I'm not sure what we are missing. I understand your point, but okay, can we come back again?
Yeah,
to
yes,
this?
sure.
Okay. Yeah. Okay, but good one. I'll just try to do something about that.
Okay. What is this constant RV? What is RV? What is RV? Constant RV?
Random variable.
Continuous random variable. Oh, I should have been more explicit. So this is continuous random variable.
Yes, we understood.
Okay. So the expectation is like this. Okay. The expectation of any function of a random variable you can replace it with the function and just put compute as it is. And the limits, you have to be very careful. Wherever this g of x is defined, or g of x, wherever g of x is defined, there only you have to take the limits. Okay. So yeah. So this is an example. We will try to solve this example. X is a continuous random variable with PDF like this. What I want is, firstly you have to find the CDF as well as the expected value of x. So this is the expected value of x. Okay. A hint, I will just give you a hint. Not a big hint. Try to draw graph of fx. So this. So how will the graph look like? It's already 350, is it?
Yes, sir.
Okay. Yeah, do this. 5 o'clock, you guys are having Python session, right?
Yes, sir.
From people, yeah. I will try not to extend beyond 4:30 or 4:40. So we'll be quick. So you should also support me. We have to go forward. We have to see lots of things. Okay. So how will the graph look like? Has anyone plotted?
Yes, sir. It will be a triangle, sir. Like
Yeah, it
over
will be
the
a
axis.
Like two straight lines.
At 0, it goes to
Meeting
1.
at y equal to 1 at point they will be meeting two straight lines. Minus
So
1,
I'll just
1.
draw.
And going
Just
down.
correct, yeah, just correct me if I'm going wrong. So when x takes -1 and +1, it will be 0. And when x
at
takes 0,
0 to
it
1.
will be the maximum value of 1. And this is how it will be. When x takes in between -1 to 0, these are the possible values of fx. And when x takes values from 0 to 1, these are the possible values of x. Correct? Is this the graph?
Yes, sir.
Yes, sir.
Yes, sir.
That top point will be 1. Yeah.
Okay. And what is this equation? Line equation?
1 minus x, sir.
And this one?
This is 1 plus x.
1 plus x.
Okay. So we will use this. That is why I asked you to compute. So remember these things. Let us try to compute fx of x. So fx of x is probability that is less than or equal to x. Okay. So now I will try to do few things here. Just observe. When x less than or equal to x, I will just split it into two things. When x is in between -1 to 0, and the next case is when x is in between 0 to 1. Okay. So what I did, when x is in between -1 to 0, and the next case I said I will just look at when x is in between 0 to 1. Okay, first thing is when x is in between -1 to x. Sorry, when x is between -1 to 0, then it is simply -1 to x fx of x dx. Correct? What is fx of x when x is in between -1 to 0?
1 plus x, sir.
1 plus x. So it will be -1 to x, 1 plus x dx.
So why isn't it -1 to 0?
Why?
So why
See, that
isn't
is a
it?
PDF, right? We are sorry, CDF, right? So x is less than or equal to x.
Yes, sir.
So I have to start from -1 till x.
Okay, sir.
Yeah. So 1 plus x, if I integrate, it will be x plus x square by 2. And the limits are x and -1. So it will be x plus x square for x. And when I substitute -1 plus -1 square by 2. So if I simplify this, x plus x square by 2 and this is half, and this is -1. If I
This is
simplify,
plus
it will
half.
be minus
Plus
half.
half, sir.
Minus and minus, it will be plus half.
Plus half. Yes, sir.
So we are going to get x plus x square by 2 plus half when x is in between -1 to 0.
Yes.
So the next thing is when x is in between 0 to 1. So till here, one part is done. And what if when x is in between
the same integral, sir?
0 to 1? So the same computation fx. So x less than or equals to x. But now x is in between 0 to
0 to
1.
x.
So now what I do is
-1 to x and then 0 to x.
So what I will do is my fx is going to change at 0. So what I will do is I will compute till 0 part. And then from 0
Break the
to
integrals,
x. So 0 to x, x because my x, till x only I have to compute the probability, not till 1. So 0 to x, fx of x dx. So here fx will be 1 plus x. But here fx will be when x is in between 0 to 1, our fx will be 1 minus x. So that is why I split this integrals. So
Sir,
here
why
fx
did
of
we
x will be different.
calculated here both the conditions?
Because we cannot substitute. If I look at, see, I can write it like this. Firstly, I can write it like this. I can write from -1 to x, fx of x dx. But which value will I substitute to fx of x? Will I substitute 1 plus x or 1 minus x?
1 plus x, sir.
Why 1 plus x? Sometimes it may be 0 to x also, right? X may be in between 0 to x also. At that time, fx of x will be 1 minus x.
But sir, here it is between -1 and x, sir.
No, here -1 and x. What if this x is greater than 0? So x is greater than 0 here.
Okay. Okay.
Okay. So from here to here, fx will be some value, and from 0 to here, it will be some other value. It will not. So it's like a piecewise defined. So I have to integrate piecewise. So what I will do is I will split this -1 to 0 fx of x dx plus 0 to x fx of dx. And here I can substitute 1 plus x because from -1 to 0, I know that fx of x is 1 plus x. And here I will substitute 1 minus x because I know that in between 0 to x, my fx of x is 1 minus x. So -1 to 0, 0 to x, 1 minus x dx. Okay. So if I compute, if I integrate it, it is x plus x square by 2, and this limits are 0, -1, this one, or this. Plus, if I integrate this, I am going to get x minus x square by 2, and the
0
limits
to
are
x.
x and 0.
Yes, sir.
So I have to just substitute 0 plus 0 by 2 minus
Sir, it
1
will be
Plus 1 by
2
2.
also.
Huh?
It will be plus 1 by 2 also, sir.
I just wrote these limits. And then
X minus x square by 2.
x minus x square by 2, and the other
Minus 0.
0 minus 0 by 2. So it will be 0.
0. Yes.
So this will be 0, this will be 0, and this will be
Plus
x
1 by 2.
minus x square by 2, and this, if you compute this, you are going to get minus half, and minus of minus half, you are going to get plus half. So you see the difference. So when x is in between -1 to 0, it is x plus x square by 2 plus half. But here when x is in between 0 to 1, it is x minus x square by 2 plus half. So collectively, I can write like this: fx of x. So I have to start from 0. It will be 0 when x is less than -1. Okay. and it will be x plus x square by 2 plus half when it is between x minus 1 to 0, and it is x minus x square by 2 plus half when it is in between 0 to 1. When x is greater than 1, it will be 1. So this is the CDF.
Sorry, sir. I don't get why you are doing that integral of.
Your voice is very, very low.
Sorry, sir. I don't able to understand that why you make this adding this integral 0 to minus 1 when you take the bound of 0 to 1.
Because my fx value will change after 0.
Mm-hmm.
Okay, fx value in between minus 1 to 0, it is 1 plus x. Okay.
Mm-hmm.
And it will change to 1 minus x after 0.
Mm-hmm.
Okay. So initially I have to integrate from minus 1 to x, and where x is in between 0 to 1.
Oh, it is because of the definition. Because of the definition. Yeah.
Definition.
Okay. Got it.
Yeah. So this is how we can compute the CDF. But the next question is the expected value of x.
Sir, but in case 2, the case 1 is we have taken in between minus 1 to 0 x. The other part is we are considering between 0 to 1. When x lies in the right side of the triangle, I'm talking about, sir. When it is in between 0 to 1, why we are considering the left half, sir?
Because this is CDF, right?
Yes,
so
sir.
I am computing the CDF. What is CDF? CDF means
less
values
than or
that are
equal
less
to,
than or equal
yes,
to
sir,
this.
That
So
means
this
from
all-
minus 1 to x. Yes,
minus 1 to x.
Yes, sir. Thank you, sir.
Very well explained, actually.
Okay. So let us move and just compute this expected value of x. So how do we compute expected value of x? Integral
minus 1 to 1.
minus 1 to 1 x times fx of x dx. But if you see here, in the interval minus 1 to 1, fx is not a single function. Fx will change after 0. So just split the intervals. So minus 1 to 0 fx of x dx plus 0 to 1
yes, sir.
fx of x dx. So now I know within this interval my fx of x I know it is 1 plus x, and within this 0 to 1 interval I know this is 1 minus x. Just substitute those. Plus 0 to 1 x times 1 minus x dx. So if I simplify this, x plus x square dx plus 0 to 1 x minus x square dx. Okay. So if I integrate it, I am going to get x square by 2 plus x cube by 3.
Zeros.
What is 0? I just integrated. Okay, expected value you are going to get 0. Okay, fine. 0, minus 1 are the limits for this. And here, if I integrate, I am going to get x. Integration of x will be x square by 2 minus x square will be x cube by 3 if I integrate it. And the limits are 1 and 0. Just substitute. When I substitute 0, 0 by 2 plus 0 by 3 minus 1 square by 2 plus minus 1 cube by 3. So for this is. And for this, it will be, if I substitute 1, I am going to get 1 square by 2 minus 1 cube by 3 minus 0 by 2 minus 0 by 3. Okay. So now this is 0 and this will be minus 1 by 2 minus 1 by 3 plus
0.
1 by 2 minus 1 by 3 minus 0. So this is 0, 0. So this half and this plus half will get cancelled, and this will be plus 1 by 3 and minus 1 by 3 will get cancelled. We are going to get 0. So the expected value of x
Yes, sir.
we are going to get to be equal to 0. So this is how you can compute the expected value.
Yeah, what is the mean if expected value is 0?
What does?
If expected value is 0, what it means here?
What does it mean is the mean is 0. Mean is 0 means x taking value 0 and the neighbors of 0 has higher chance.
Okay.
Okay. So you can see here also from the PDF also you can see, take a look. So it is symmetric around 0. Okay. So from the graph itself you can get directly that the expected value will be 0.
And from graph we can see, sir, E of fx will be 1, is it? From graph it looks like fx, E of the function.
E of that function will somewhat be like this, right? Here.
Centered around, okay.
Or center, or it is very close to this.
You've given the formula, no sir? Using that we should find out. Instead of x, we should use fx.
If you wanted to use fx, then substitute fx.
Okay.
Okay. Okay. So if I want to compute variance is also okay.
So, sir, in the examination, if we plot the graph and find the expected value, so through the graph we can conclude that.
See, through the graph, how you can conclude is it is uniform in this interval, not uniform. So you see the symmetricness, okay? It is symmetric around 0.
So if it is symmetric around 0, so we can easily calculate. Okay, it is expected value is 0.
Expected value will be 0.
So no need to calculate like that.
I don't say no need to calculate. 99.99%. These results will follow, but maybe there might be some exceptions. You have to be sure about. Okay. One thing I can say. Okay, it works, I guess. But anyway, for.
So you say
it's simple, sir. We can like try and do it.
So you said previously in the quiz one, we have some tips and tricks.
Sir, it seems to be difficult.
We will talk now. Which one? From graph it seems to be difficult. Just go through the standard approach we have. Okay. So graph it requires some intuition. It requires you have to solve a numerous number of problems. Then you will get an idea which graphs, where the mean will lie. Will it lie to some value? You can easily guess. So you have to practice more problems for that. So variance of x also you can compute. For variance of x, you need to compute the expected value of x square. Okay. In place of x, just substitute x square. So in place of this x, if I wanted to compute expected value of x square, just do -1 to 1 x square fx of x dx. Okay. So and compute expectation of x square. Then substitute expectation of x square. So expected value of x is 0 anyway.
Yes, sir.
So this will be 0. So variance of x will be equal to the expected value of x square. So like this you can compute variance.
1/6 I got, sir.
Oh, you compute.
Yes.
Very good.
Yes, sir.
Okay. Just cross check.
Is it 1/6 or not?
Yeah. So you can cross check it. X square. So it will be x cubed by 3 plus x power 4 by 4.
Yes, sir.
X cubed by 3 and here also x cubed by 3.
X power 4 by 4.
X power 4 by 4.
I'm again getting 0, sir.
Again getting 0, is it?
Expected value of x square as well.
Mean is 0, so symmetry by symmetry also you can see.
So how will the x square will look like?
Sir, I think variance should not be 0, sir. Right?
Yeah, it will be 1 by 6.
Should not be 0.
Mean is
1
0,
by
sir.
6
Mean
I
is
got.
0.
I got.
Okay, let me compute then. So expected value of x square. So we have to -1 to 1 x square fx of x dx. So from here again we have to split the integrals because fx of x will be different in the intervals. So 0 to 1 x square fx of x dx. So from here -1 to 0, I will just directly write it. This is 1.
Yes, sir. It is coming to be 1 by 6 only, sir.
1 plus x, and this is 1 minus x. So x square plus x cube dx, and this is 0 to 1 x square minus x cube dx.
Yes, sir.
Integrate it, we are going to get
X cube by
power
3.
3 plus x power 4 by 4 0 1 plus
Minus
x
1,
cube
sir.
by minus 1 x power 4 by 4 1 0.
1 0.
So this is 0. First term will be 0.
Yes, sir.
And this will be 1 by
Minus
4 minus 1 by 4 plus 1 by 3.
1 by 3.
Yes, sir.
Plus 1 by 3
Minus 1 by
minus
4.
1 by 4.
It's 2 by 3 minus 1 by 2.
Yeah, 2 by 3 minus 1 by 4.
1 by 2, sir. Minus 1 by 4.
Minus 1 by 4, 1 by 2. 4 minus 3, 1 by 6.
It's 1 by 6. Yes, sir.
Yeah, 1 by 6 is correct. Let's move. So that is how you can compute expectation of a random variable and also expectation of a function of a random variable. And the next part is discrete continuous joint distribution. So in this case also, there are two random variables x, y which are jointly distributed, where one random variable x is discrete. When I say it is discrete, it has some range and some PMF, probability mass function, as px of it. Okay. And also, if I know for each x, so x is discrete, so I can talk about each x belonging to the range of x. If you have a continuous random variable yx, corresponding random variable yx for each x with PDF fyx of y. So if I have this, that means what am I saying is this yx which I am referring to is actually y given x is equals to x. So for this x, if I know the distribution of y, so that is y given x is equals to x, this distribution y given x is equals to x. Now this fyx of y, which is called the conditional density of y given x is equals to x. So here the condition given to be x is equals to x. So capital X is equals to x. So I am looking at the conditional density of y. So why I said density is because our y is continuous here. So y is continuous, x is discrete. Look it in that way. So what our setup is, x is discrete, and for each x, if I know if I have a continuous random variable yx, so which is y given x is equals to x, with the conditional density of y given x is equals to x, like this, y given x is equals to x of y. So this is the conditional density of y. So if I know the conditional density and the PMF of x, which is the discrete PMF, then I can compute the marginal density of y, which is fy of y. And this marginal density of y will be product of the PMF times the conditional density. So this is the PMF of x. And this is the conditional density. Okay. So the product of these two for all x. So I will compute the product of these two for all x and I will just sum it out. Okay, this will give me the marginal density of y. So for example, if I have this example, so our setup is this. I know x follows some discrete distribution which is binomial 2, half, and I also given a conditional densities of y. So the range of x, I know what is the range of x. So if I said binomial
0 1 2,
0, 1, 2 will be the range. So for each x, so x takes value 0, x takes value 1, x takes value 2. So when x takes value 0, I look at the conditional density of y. So y given x is equals to 0, let's suppose say follows normal 0, 1. Like that, y given x is equals to 1 follows normal 1, 1. Similarly, y given x is equals to 2 follows normal 0, 4. Now we are interested to find fy of y, so which is summation x taking values 0, 1, 2 px of x times fy given x is equals to x y. So these two things I have to find. So firstly we will find the PMF of x. So what is the probability that x takes value 0?
Two C 0 into 1 by 2 power
binomial.
0. Yes.
1 by
Into
2
1 by
part
2.
1 by 2 part 2.
Power 2. 1 by 4.
Okay. Correct. So this is the PMF. So we got this. And also this is given. It follows normal 0, 1, normal 1, 1, normal 0, 4. So if we know the normal distributions PDF, we can easily write this. Do we know? So what is fy of fy given x is equals to 0 of y? Standard normal.
1 by sigma
Root 2 pi e to the
minus
power of
x minus mu.
x minus
X minus. So it will be
it will be 0. Yes.
By
2
correct.
sigma square.
Sigma square is 1. So sigma and mu I just substituted. So people who don't know normal distribution, I am going to write it here. So f standard normal, or let's say normal, we will take normal. Fn of n will be 1 by root 2 pi sigma into e to the power minus
X minus mu.
n minus mu whole square divided by 2 sigma square, where n follows normal mu sigma square. Okay. Or x. Let's take x. So this is the PDF of a normal distribution which has mean mu and variance sigma square. So just substitute mu and sigma square here. We are going to get this times probability that x takes value 0 plus. Okay. So the next thing is fy given
X is equal to 1.
X is equal to 1 y into probability that x is equals to 1 plus fy given x is equals to 2 into y probability that x is equals to 2. So just substitute it everything. So root 2 pi minus y square into 1 by 4. This will be 1 by 4. Similarly, now you see this is normal 1, 1. So that will be 1 by root 2 pi into e power minus y minus 1 whole square by 2 into 1 by 2 plus this is normal 0, 4. So 0, 4 is 1 by root 2 pi into 2. So it is sigma. So sigma is 2. E power minus y square by 2 times 4, 8 into 1 by 4. Okay. So you simplify it. Once you simplify it, you are not going to get normal again. So this is not a normal distribution distributions PDF. So this is mixed normal, multi-normal. So you have multiple normal distribution sum. So we say mixed normal or mixed Gaussian or mixture of Gaussian. It is actually not an normal. Normal or Gaussian both are same. So this is called mixture. It's mixed with few normals. Okay. So this is how you can compute. See, you can easily guess when the question is having one discrete and other continuous. You can directly guess that that question is from this concept. Okay. No other concept we have dealt with one discrete and other continuous. Okay. When you see in any question, when you see you are having two random variables and one is discrete and another is continuous, then you are pretty much sure that you are in week 5 one of these lectures. So you have to recall whatever happened in these lectures. Okay. That is about.
Yes.
And from week 6, I will just quickly discuss. I will just go through the examples mainly. So week 6, we will start with joint density. So what is joint density is, if I have a function fx, comma y, is said to be joint density function if it satisfies these two conditions. The first condition is whatever the function I take, the function value should always be greater than or equal to 0 for all x comma y. So within the domain x comma y, my fx comma y should always be greater than or equal to 0. And the second condition is if I integrate along x and integrate along y, my this function fx comma y dot dx dy should give me 1. So this is the integral for y and this is the integral for x. So whatever the limits you see, these are the limits of y and these are the limits of x. So if I integrate along y and along x, and see, simply you integrate along x and then along y, you have to get 1. Okay, these are the two conditions you have to check. So whenever a question is given, you have to check these two conditions first of all. And these things we have discussed already. If there is an event, so for every f of x comma y, if it is a joint density fx comma y, then for that joint density there exist two jointly distributed continuous random variables x and y. So if I have a joint density, then for that particular joint density, I will definitely have two jointly distributed continuous random variables x and y, such that if I look at the probability that x and y takes in some region A, then the probability that x comma y will be from that region A, I have to integrate along that region A. So it is enough to integrate along region A. No need to integrate from minus infinity to plus infinity.
Sir, one doubt I have. So like there are two random variables, and if you are like double integrating them, we are finding integration over an area, right? The volume above that area. So if it's a line, not a region, if it's a line, suppose I say y equal to this and x lies in this range. So it's a line, right? Or if I say x plus y equal to this, that's also a line, right? So what about that?
What about that?
If I have to integrate over a line, not about above an area, will that be 0 or?
Sir, I think it will be 0, sir.
It will be 0 only.
So if I say y equal to this and x lies in this range, like I say y equal to 5 and x lies between -1 and 1 for a joint distribution function. So that will be 0?
That will be 0 only, right? You are saying that y is 5, right? For one integral, the limits will be 5 to 5.
But sir, marginal density is this only, na sir? Or we are fixing the one and negating the other.
Marginal density is
this only, na sir?
You are computing the probabilities, right?
Yes,
so
sir.
This gives me probability, that gives me density. See, you understand single variable, right?
Yes, sir.
X is following uniform 0, 1. When I say 0, 1, what is the probability that x takes value 3?
0.
sorry, x takes value half.
0.
0. But fx of half will not be 0.
No, sir, it will not be.
Correct. So even here also, if you wanted to compute the probability that my y is taking value 5 and x is in between some interval, the probability will be 0. But when I compute the marginal densities, it will give me the densities. How high chances are there that my x and y takes those values. So you understand the difference between the probability and density.
So even in the graded assignments, we have at least 2 questions in this week where they are calculating probability, where y is taking some value and x is in some range. And what the solve with the session was not conducted for this week, and the video was uploaded. And in that video, what ma'am did is just put up the value.
Put up the value into the density, right?
And then integrated it for other variable.
I hope that you are talking about this joint and conditional probabilities.
Yeah.
Right? Yeah. We will discuss those while we do the problems. Okay. I have that problems with me. We will discuss that.
Okay. Sir.
Why it will be like that. But as of now, if I wanted to compute the probabilities within some region, I have to integrate along that region. Okay. And corresponding limits, you have to, finding the limits is the difficult part. And we will try to understand how to find the limits of for each integral. And this fx comma y, let's move. And this fx comma y, sometimes, not sometimes, we will usually write it as fxy subscript xy, x comma y, which is called as the joint density of x and y. So both the denotions are same, but we use this more often. And next comes the support. Again, the support of x comma y, the same support. So for single random variable, our density should be strictly greater than 0. Even here also, if I look at the support of x comma y, all xy's such that this joint density is strictly greater than 0. That's it. So correlate with density and joint density. So if it is single random variable, our density function value should be strictly greater than 0. Here also, if I look at the support of x comma y collectively, jointly, here also the support will be all xy's, all the point xy's, such that my joint density is strictly greater than 0. So those are few observations about this joint density. And we will see few examples of this jointly distributed random variable. So first and foremost thing is the standard one. If it is uniformly distributed on a 2D plane, okay. So that means consider a region D.
Sir, sorry to interrupt. Sir, this recording will be there on in the live sessions tab, right?
This recording we will upload it in the live sessions tab.
Okay, sir. And sir, the notes.
Notes I will upload. Notes I will upload.
Sir, where? Sir, where will you upload the notes?
Live session notes. Live session notes. There is a tab called live session notes in the live sessions only.
Sir, today or tomorrow?
Maybe live session notes we will upload it. I will try to upload it by night. I will ask them to upload it. And even video also I will ask them to upload it as soon as possible. It should generate first of all.
Without notes, I'm not able to solve mock.
Sure. I will most probably by tomorrow afternoon. Before tomorrow afternoon, you will get notes and YouTube recording also.
Sir. Sir, I'm able to see supplementary contents short notes. Besides that,
no, not that. Just click on live sessions.
Yes, sir.
And just go down in live sessions. Just go down.
Okay, got it, sir.
So there is some tab called live session notes.
Yes, sir.
So there you will get the notes.
Okay, sir.
Okay. Yeah.
Thank you, sir.
Yeah. Okay. So this 2D uniform distribution is quite famous distribution. So this, how this is defined is, if you consider a region D in R2, R2 means it's XY plane. In XY plane, if you consider any region D, so region means an area with total area some D square units, then I say my XY is uniform in that region D if they have the joint density as like this. If they are having the joint density as 1 by area of the region, then this particular, if X and Y having this joint density, then I say X comma Y is uniform in the region D. So even the same thing you can correlate. When X I say single random variable, if I say uniform between A to B, so what I will do, I will, for the density function, what I will do, 1 by B minus A, 1 by the length of this interval. So for interval, we will look at the length. For region, we will look at the area. Okay. So like that. So 1 by area of the region. There 1 by length, here 1 by area of the region. So it will be 1 by D when X comma Y is in the region D and 0 otherwise. So this is uniform distribution. If my joint density is like this, then it is uniform. For example, like this. So I say X comma Y is uniformly distributed in the region D, and the region D is given to us like this. So all XY's such that mod X plus mod Y is less than or equals to 2. So easy examples, I have done it in the week 6 revision session. It's like first session, activity practice session. So I just want to take some little complicated examples here.
Sir, and that day you gave some five problems to us.
I have that also below.
Yes, sir. I just want to know the answers, sir.
Yeah, we will solve it again. We will solve it again.
Thank you, sir.
So firstly, we will solve this. So I have given the region D now. What I want is just try to plot the region D and try to find fxy. Then try to find this probability that 1 less than x less than 2 comma y greater than 1, and then probability that mod x plus mod y less than or equals to 1. Okay. So everyone please try this. Will it be circle?
First one 8, sir.
No, sir.
First one is 8.
Not a cycle, sir.
1 by 8.
Okay, 1 by 8. You said 1 by 8 within the region D, correct?
Yes, sir.
And 0 otherwise. Okay. So will it be circle?
No, sir.
No, sir.
No. Rhombus.
Rhombus.
Right. So how do you do?
I have separated as 4 lines.
Yes, sir. Solve this equation for different quadrants, sir.
Correct. So I just said if there is inequality, anytime if there is inequality, just make it equal. Okay. After making it equal, you see mod x can be x or minus x. Similarly, mod y can be y or minus y. So if you expand it, you will get x plus y is equals to 2 if x greater than 0, y greater than 0. Minus x plus y is equals to 2 if x is less than 0, y is greater than 0. Minus x minus y is equals to 2 if x less than 0, y less than 0. And what is the other one? X minus y is equals to 2 if x is greater than 0 and y is less than 0. So you see x and y are greater than 0, then mod x will be x itself.
Sir, in the problem, mod x plus mod y less than equal to 1.
Which problem?
You are writing 2, that's why.
It's 2
I
only.
have given 2, right?
Oh, okay.
This is my problem. Okay. See, whatever I have given you, you should solve it in that way. Okay. So like this. So just equate it and you will get 4 lines. And you will get the regions also, in which region you have to draw those lines. So when x is greater than 0 and y is greater than 0, that means first quadrant. So in this quadrant, you have to draw x plus y is equals to 2. So if I draw that, somewhat it will be like this. So let me plot the 2 minus 2. 2, 2, minus 2 and minus 2. Okay. So now it is like this. And in the interval, when x is less than 0 and y is greater than 0, that is second quadrant. So in the second quadrant, I have to draw the line minus x plus y is equals to 2. If I draw that line, I will get like this. And x is less than 0, y is less than 0, it is third quadrant. And in this quadrant, I have to draw minus x minus y is equals to 2 line. Like this. And finally, the last line x minus y is equals to 2 when x is greater than 0 and y is less than 0. So that is fourth quadrant. And I have to draw this line. Okay, after drawing this, so on this rhombus, mod x plus mod y will be equal to 0. And this rhombus breaks xy plane into 2 regions. So the inside region and the outside region. So one region will follow less than or equal to sign and another region will follow greater than or equal to sign. Okay. So one region will follow not equal to. So one region will satisfy this condition and another region will satisfy this condition. You can check. So whatever the point you pick inside the rhombus, this condition will be satisfied. Mod x plus mod y will be less than 2. And whatever the point you pick outside the rhombus will satisfy greater than 2. So we require less than or equals to 2. So that means this region. And once I get this region, and I said my xy is uniformly distributed in this region. So once it is uniformly distributed, I know the joint density function. So I know how to find fxy. So it is simply 1 by area of that region. So what will be the area of this region D? This is the region D.
4 times the area of
4 times the area of this triangle.
Yes, sir.
So area of this triangle will be 4 times
half
area
base into
of triangle. And this is 4 times half into height is 2, base is also 2. So 2 times 2, it will be 8. So once the area of the region D is 8, my joint density will be 1 by 8. Okay. So this is 1 by 8. I got it. What about the second one?
1 by 16 I've got, sir.
1 by
16.
Okay. Any other answers?
I got 1 by 8, sir.
1 by 8. Any other answers? Okay, what is the region that represents 1 less than x less than 2 comma y greater than 1?
It's a triangle, sir.
First quadrant triangle, sir.
Triangle?
Yes, a triangle in first quadrant.
Yeah, that's what it is.
No, sir.
Okay, let me wait for the right answer.
Point, sir.
This is wrong.
Huh?
Point.
What is point?
Second one, sir.
No, I asked the
It's
probability.
0, sir. So second it's 0.
We are getting region as a point.
Okay. You are getting region as a point means the probability will be
0, sir.
See, you can see here also. Mod x plus mod y is less than or equals to 2 is our region. I want x to be in between 1 to 2 as well as y to be greater than 1.
Oh, both will not happen.
Both will not happen at the same time. You can
Sir.
see. If I draw the region of that also, so this is our minus 2, minus 2, minus 2, minus 2. Okay. Let's say what is y is equals to 1 line. This is y is equals to 1. This is 2, minus 2, minus 2, 2. Suppose this is 1. So it is given that y is greater than 1. So y is greater than 1. This is the region. Possible region. And also at the same time, x also should be in between 1 to 2. So can x be in between 1 to 2 in this region? In this region, x is in between somewhere minus 1 to 1.
No, sir.
So x being 1 to 2 means it should be in between these two. Okay. So that means it should be somewhat like these things. Okay. So this region, I am talking about this region. Y greater than 1 and x is in between 1 to 2. So this region. And in this region, fxy is 0. So we have fxy values only within the rhombus. And this region, what I have given, will go outside my rhombus. So you see this open rectangle. So this is the region where x will be in between 1 and 2 and y is greater than 1. Yes or no?
Yes, sir.
Yes, sir.
This is the region, right? This is 1. Y greater than 1 and also x should be in between 1 to 2. This will be the region. You can check. Any point you pick, x values will be less than between 1 to 2 and y values will be greater than 1. So the probability that x being in between 1 to 2 and at the same time y being greater than 1 will be 0. It will not be possible. Now what will be the last?
Yes. 1 by 4 I am getting.
1 by 4.
1 by 4.
1 by 4. Correct. So you have to find the region in which this mod x plus mod y be less than or equal to 1. That will be a smaller rhombus. Correct? This region. So in order to compute the probability, when it is uniform only, you just compute the area of this divided by total area. So area of this small rhombus will be 4 times half into 1 into 1. So each triangle height and breadth will be 1 and 1. So it will be half into 1 into 1. So it will be half units. So one rectangle is half units. 4 rectangles will give me the whole blue region. So 4 times half is 2 divided by total area of D, which is 8. From there we are going to get 1 by 4. Okay. See, the problem might look very tricky, or being this mods less than or equal to, combining joint and giving regions, everything might look beyond your scope. But once you break it into pieces and if you understand the question properly, what we are asking, then you will get the right answer. See, the part 2 is basically if you have some intuition that my region is in between, see, x and y should be always, if I do the sum, it should always be less than or equals to 2. But in part 2, if you see, x values are between 1 to 2 and y also greater than 1. That means if I look at the sum of x plus y, it will nowhere come below 2. It will always be above 2 because x is greater than 1 and y is greater than 1. X plus y will always be greater than 2. So from there directly no need to compute anything. If you have that intuition that what region will it be, so how to draw these regions, then you can directly substitute 0. So that is what we expect. So you, for this you have to solve more and more problems. Okay.
Yes, sir.
That is what I suggest. See, it's not always.
So from where we will find the problem, sir?
That is what. From where will you find this problem is because you can create a problem. You yourself can create. It's not joke. See, I have given less than or equal to 2.
Yes,
you
sir.
can make it something else. You just look at between this region also, less than or equals to 1 to less than or equals to 2. So this region.
Okay, sir.
So this is the region, and then you randomly take you whatever you feel, you randomly take and try to find the probabilities. So you can always cross check with us. Okay.
Okay, sir.
So you create a question, you create question by yourself, and you have to be in our foods. Like how can an instructor can ask a question? So that is what you have to do if you have the time. If you can do that and break it, then every problem will be easier to. Okay. So similarly, that is uniform. What if it is non-uniform? What if the joint density is given like this? So it is a k times x square y when in between 0 to x is between 0 to 1 and y is between 0 to 1 and 0 otherwise. So what I asked you is, firstly I asked you the value of k for which this fxy is a valid joint density function. Then I have given some 4 problems. Even in the previous session also I have given this.
Yes, sir.
Just quickly try to solve this.
Yes, sir.
Or okay, we will just go one by one. So what should be the value of k for which this particular fxy to be a valid joint density function? I have discussed 2 conditions.
Yes, sir.
So what are the 2 conditions?
At every point it should be greater than 0.
And then what is the second condition?
And area is 1.
Double integral 0 to 1, 0 to 1.
Greater than equal to 0 in first condition.
No, greater than 0. Greater than 0 only, right? Sorry.
Greater than equal to.
Greater than equal to.
So the second condition is if I integrate along the support of x and support of y, I should be getting 1. So just do this. So first thing you can see x square, y square, and x is between 0 and 1. X and y is between 0 and 1. So you don't need to worry. So the product will always be between 0 to 1.
Yes, sir.
6.
I got it as 6, sir.
6. So we have to integrate it. 0, 1, 0, 1, k, x square, y, dx, dy. So when I integrate x, you just keep y as constant. So 0, 1, ky into x square I am integrating. It will be x cube by 3. And the limits are 1 and 0. So it will be k by 3, ky by 3. So integral 0 to 1, ky by 3. Just put the limits. X is equals to 1 and x is equals to 0. So 1 by 3 minus 0. So ky by 3 dy. And again, I have to integrate with respect to y. So k y square by 6, 1 and 0. So it will be k by 6. And what we said, in order to be a valid density, this k by 6 should be equal to 1. So from there we get k is equals to 6.
Yes,
so now the problem first part is done. So k value we got it as 6. Now what we asked you, what is the probability that x is in between half to 1 and y is greater than 0? So this is an event. Okay. So if I draw the region of this, it will be like this. 0, 1, 1. This is y and this is x. But make sure this is not uniform. This has different densities. Okay, it's not uniform. But it will lie in this region only. X and y will take values from this region only. So remember that part. When we are wanting our x and y values within some region, so which region I want? I want from x from half to 1 and y from greater than 0. So that means within this region I want. So in this region, I have to integrate. So that is sufficient. So for
sir, how did you draw that square, sir?
Because
limits 0 to 1, 0 to
1. 0 based on limits.
The region in which joint distribution is different.
Yes, sir.
But it is not uniform. That's it. That only difference is it's not uniform.
We are talking about region.
Yes. Region. So no area will play any part here now. So always you have to integrate within this region. So our event is this now. X is in between half to 1 and y is in between 0 to 1. So that is how I will integrate. So 0 to 1 y limits and half to 1 x limits.
Yes, sir.
6x square y
dx
dy. So if I integrate it, I will get some value.
7 by 8 I got, sir.
7 by 8. So you can simplify this. We will get 2y x cube and limits are 1.5 and 0 1 2y and 1 minus 1 by 8 dy. And from here 0 to 1 it is 7 by 4 y dy. Now if I integrate it, I am going to get 7 by 8 y square 1 0. So it will be 7 by 8. That's it. So here the event is x is between half to 1 and y is between 0 to 1. So y greater than 0 means y can only go till 1. So that is more or less saying like this. Okay. So you just substitute that limits. Now the next part. What is the probability that x is greater than y? So which region? So always go with regions. So now forget about areas, but look at the regions. Even for non-uniform also, look at for region. Which region will it represent? So which region will it represent? So 0, 1, 0, 1. I said one thing in that session also. Even though it is greater or lesser, or you just forget that and replace it with equality.
Equal to.
So now x
So
is
1
equal
1
to
sir.
y.
Y is equal to.
So y is equals to x.
Yes.
Draw the line y is equals to x. Once you draw the line y is equals to x, this line, on this line it will be y is equals to x. And below this line it will be y less than x. And above this line will be y greater than x. Okay. You can check it with by taking 1 point. 1 point is enough for check. Okay. So we want x to be greater than y. So this is the region. Right, in this region. This is the region.
So this probability did not require to be like a number. It can come as a function of x or y, right?
Right. See, we are asking you to compute the probability, right? So probabilities will always be in between 0 and 1. Range of probability will be between 0 and 1, right?
Okay, sir. Maybe I put some limits wrong.
Limit, you might have gone wrong in limits. So now I have to integrate within this region. That's it. So what will be the region? How do I find the limits of this region? So what I can do is, you fix one thing, either y or x.
X.
You fix x. So for x, this x we will fix. Okay. For this x, you look at the limits of y in terms of x.
0 to x.
So from 0 till how long y can go? Till here.
X.
What is this here? So this is y is equals to 0. What is this point? Y is equals to?
Y equal to x.
X. See, this line is y is equals to x line. So y can go from 0 till this point is y is equals to x. Okay, 0 to x. So my y limits, just write the limits of y, 0 to x. And then write dy here. So I'm going to integrate y first. So that is why I have written dy. Then for this x, my y limits are from 0 to x. What are the possible values of this x? How can this x take? X can take from 0 till 1. Yes or no? This x, whatever x I have fixed, this x can take values from 0 to 1. So within this region, it has from 0 to 1. So just substitute 0 to 1.
Sir, what I did is I took 0 to 1 inside integral and 0 to x outside integral. That's why it came as x.
No. That you shouldn't do. Whatever the limits you are taking, that will correspond to the respective dy or dx.
No, sir, I'm just integrating x only. I'm integrating x only inside. But I'm integrating x first and y later.
No, see, always the variable should come inside.
No, then it should be 0 to y, no? You can take the vertical strip also. I mean, instead of vertical strip, you can take the horizontal strip also, no?
You can take the horizontal strip also. Then what happens is, once you take the horizontal strip, you see, this is y. Okay. Once you fix y, my x limit will go from this
y
is x is equals to y to x is equals to 1.
Yeah.
Okay. So then the limits will be y to 1 for dx.
And
then
to 0.
Y can move from 0 to 1.
To 1, yeah.
So here or till 1. So this is 0 to 1. These two are equal.
This should have been the...
I took the limits of other and I put interchange them. Okay. Got it.
See, always you see the inside limit can have variables. Y or x. Outside one will have numbers. So xy, this is dx dy. When I strip along horizontal stripping, it will be dy dx when I strip vertical. So fix one thing, either y or x, you fix one thing. Then compute the limits of the other variable in terms of the fixed variable. So I fix x. Once I fix x, I find the limits of y in terms of x. So y can go from 0 to x.
Excuse me, sir. Sir, why we take that point y is equal to x?
Because we want the probability of that, right? Probability that x greater than y we are trying to find.
But the thing is, the whole line is actually y is equal to x wherever we put that point.
See, I just took, if this is x, if I take it as x1, okay, then it will be y is equals to x1, right? What is this point? I want this point. This point. If it is x, what is this point?
This point is y is equal to x. Why?
In this line, this line is y is equals to x, okay? If this is 1, what is this value? 1. If this is 2, what will be this? If this is x, if I say this is x,
yes,
what will be this?
This will also be x.
Huh?
X.
X. So that is what I have taken. So here I am looking at here, y is 0 till it can go till y is equals to x. If
but
I fix x.
This is what I am saying. But every point on this line is equal. Y is equal to x. So how can we take any particular point? Every point is actually y is equal to x.
See, this x is not random. This x is not variable here. I just fix the x. Okay, let's say x naught. Okay, fixed value x naught. Yes. Corresponding to that x naught, what are the limits of y? Okay, this is x naught. This will be x naught. So this is the strip I am looking at. This strip.
Yes, sir.
Okay. X has taken x naught. Y can take from 0 to x naught.
X naught, yeah.
Correct. So that is what. See, that x is a x or x naught. I just said x is fixed here for that particular y. X is fixed.
It could be any point on that line.
It could be any point on that line.
Yeah. Okay.
That x is fixed. Once I fix the x, corresponding to x, I find the limits of y. Okay, here it is y is equals to x. You might be confusing. Let's say y is equals to x plus 1. Okay. Or x square.
Yeah.
Okay. This x is variable, but whatever I am fixing here, x or x naught, that is fixed value.
Yes.
Okay. For that. Now you can compute, right? So fxy of x comma y I know, which is 6x square y. So just substitute 6x square y and integrate it. So integrate y first, then x here. Here you have to integrate x first and then y. Okay, finding the limits are the difficult. Once you put the limits, it's just the integration. So once you are integrating y, you just keep x square constant and integrate it and put the limits. Then integrate along x and put the limits. So you'll get it. And what about this one? Probability that y is less than x less than 2y. Which region will it represent? I will just give you the limits. You just compute the values.
Then between y is equal to x and
sir,
x
please
is
one
equal
scroll down, sir. I just want to note down the limits. Yes, sir. Yes, sir.
So now we are interested to find
x in between y and 2y.
So the same approach. Remove the inequalities. Just put the equalities. So x is equals to y, I have to draw. So if I draw x is equals to y, this is the line. And how will be the x is equals to 2y line be?
It will pass through the middle of that vertical line.
Parallel to that, sir.
X is 1, y is half, right? Like this?
Yes, sir.
Correct. So this is y is equals to x line, and this is y is equals to, y is equals to x by 2 line. Okay. X is equals to 2y. Okay. So x is equals to 2y line, and this is x is equals to y line. Okay. Now what we require? We require x to be greater than y. So x greater than y will be below this line, So that is this. And next is x is less than 2y. So x will be less than 2y in this.
Hello, sir.
Hmm?
Sorry, sir. Actually, earlier I tried to talk. My mic was not working. See, the previous sum, no, like we have calculated previous sum. Now here, can't we use the area formula? Even when I watched Andrew sir's video, I had the same doubt.
Yeah.
See, it is actually when we plot the area as such, we get two triangles. So why don't we, where to use the area formula and where do we use only integration, sir? I had that doubt because it comes like a two triangles. So can't we use the area of a triangle formula and calculate the probability, sir?
No. See, area will only come into the picture when it is uniformly distributed in that region.
But okay.
You understand uniform distributed, right? Just now we discussed 2D uniform distribution.
Yes, sir.
If my x and y are distributed in a region, and in that region also if it is uniformly distributed, then only you can bring areas into the picture. If it is not uniformly distributed, if it is distributed like this, if the joint density is depending upon x and y, x square y like this, and this is non-uniform case. Okay, in non-uniform case, you should always find the region and you should actually integrate along the region.
Okay, so there we should never use the area formula. Actually, so while watching Andrew's video also I had the same doubt because why come he's not using area formula all on a sudden. So so only if it is uniform we need to use area formula. So if it is not uniform we have to integrate only. Okay, sir. Thank you, sir.
Yeah. Okay. So let me come back. So this blue region represents y less than x region, and this green region represents x less than 2y region, and we need the common region. So that common region will be this. And also we don't require beyond our support also. So let me erase that. So we don't require beyond support also. So this is the region. Okay, I got the region.
Sir, how the x less than 2y be the middle region?
See, when you draw x is equals to 2y line, on this line it will be x is equals to 2y, and above this line it will be x less than 2y, and below this line it will be x greater than 2y. You just pick randomly any point.
Okay.
X will be less than 2y. This condition will be satisfied by any point. Okay. Every line will divide an xy plane into two regions, and each of the regions will follow different signs.
Yeah.
Okay. So from there, the common region will be this. Now the main task is to find the limits. So I have to integrate along this region now. So if I have to integrate along this region, I fix x first. Once I fix x, I will try to find the corresponding limits of y. So y is equals to something, y is equals to something in terms of x. So this line is basically x is equals to 2y, and this is x is equals to y. So what will be the limits?
X by 2 to x, 0 to 1.
Correct. So from x by 2 to x. So this will be x by 2 to x dy. We are integrating y first. Then x can take any value from 0 to 1. This can happen, this can happen, even this can happen. This also can happen. So from 0 to 1 it can take dx, and this is 6x square y. So again you have to integrate first with y, then integrate with x. You will get a value. Okay. So this is how we have to do. And finally,
that means wherever the function will be defined, we will integrate it by that first.
Wherever it is the event, the event is being asked.
Yes.
Okay. This is the event now. So find this region. Find this region. So what is asking? You have to find that region and you have to integrate along that region. Finally, it is given that x plus y is greater than 1. So again, you have to follow the same approach. Even though it is greater than 1, just try to draw the line x plus y is equals to 1 line. So x plus y is equals to line will be
diagonal, sir.
Like this. So this is 1. So here it is 1 and 1. So this is x plus y is equals to 1. And what we require now? X plus y is greater than 1. So this x plus y line will divide it into 2 regions. And the above region will give me x plus y greater than 1. And the below region is x plus y less than 1. So you can check. You just substitute 0, 0. 0, 0 will be 0 plus 0 will be 0. 0 is less than 1. It is true. So in this region, all the points, whatever the point you pick, that will be less than 1. And whatever the point above this line you pick, you just take sum of the coordinates, you just take, that will always be greater than 1. So our required region now will be this. This is the region that represents x plus y greater than 1 in this support of x and y. So now if this is the region, I have to find the limits. So fix x. Fix x. If this is x, find the corresponding limits. What is this and what is this? So this is y is equals to 1. So I have to go till 1.
1 minus x.
And you have to find this point. Yeah. So if I write y in terms of x, 1 minus x it is. So this will be 1 minus x. So 1 minus x to 1. And this x can go from 0 to 1. dy dx. Like this. So firstly, two things you have to be very careful. First thing is identify the region which the event is being asked. So once you identify the region, next putting the limits. These two are the main things where you can go wrong easily. So for this, even you have tutorials, tutorial examples, activity questions. So you just practice it, you just parameterize it. So if it is given 2, you just take 4 and again try to solve it. If it is in first quadrant, if it is given like x plus y greater than 1, you just try to find for x plus y less than 1 also. So like this, you try to find it. So that is about
in the above question, how to find the horizontal.
How to?
So we take the vertical line x. If we take the horizontal.
If you take the horizontal, you just tell me. You fixed y. Okay, this is y. Let's suppose say y. Now once I fix this y, I just look at the limits of x. So what is this x and what is this x? So anyway, this x is 1.
This is
so I have to integrate it 1. So what is this? X will be?
Y minus 1.
No, this is x plus y is 1. 1 minus y.
Oh, yes.
Correct? So 1 minus y. And again, this y can go from 0 to 1.
Yes.
And here this is dx and dy. So these both are equal. You compute, see, that is what I am saying. You compute both the integral values, you should get the same value. So then you will get to know, if you understand one, if you understand the horizontal stripping or the vertical stripping, you will definitely understand the other one also. So try to give the limits to both of them. Try to compute the value, you should get the same value.
So in the previous y, x is between y and 2y.
There you want
take the
dx.
horizontal.
If you take horizontal, what happens? this point and this point, you have to find x in terms of y. So it is going from y to 2y.
Okay.
Correct? So like that. So try to solve the problems. And yeah, I have one more example which involves this conditional density, independence, and marginal. So marginal is basically when I have a joint density. So if I want the marginal density of x, what I will do is I will integrate along unwanted y from minus infinity to plus infinity, fxy x comma y dy. And if I want the same, similarly, if I want the marginal density of y, the unwanted is x, so I integrate along x from minus infinity to plus infinite, fxy x comma y dx.
So
same thing. Yeah.
Like fx of x is like x we are keeping the constant, y we are changing, right? So x we are keeping the constant, y we are changing. If you look like this will be a line. This will not be a region, definitely, right? If you look at even if you look in 3D, it will be a plane at most, right?
Plane. Correct.
Yeah. So and its volume will be 0. So its density will be 0, but sorry, its probability is 0.
Probability is 0.
So what we are calculating is just density, right?
Density. Density actually involves, you see this dy, right? Actually involves a slight width inside this. So when we talked about why the continuous at one point is 0, why not it have, see even there also it will have some probability. Okay, so
yeah,
that is what we do. So that dy plays a very big role. This dy, the delta, small width which it offers will give us some positive density. Okay. But when we talk about probability exactly at that point, it will be 0.
Okay, got it.
Okay, yeah. So these are the marginal densities. Again, the same things. There are no new things are coming into the picture. Only we have two random variables here. So previously, we have seen a single random variable. Here we are seeing two random variables. So even independence is also the same thing. Whatever we have for discrete, the same condition for continuous also. X and y are independent if and only if my joint should be equal to product of marginals. So joint, this is joint density now. So we will talk in density terms. Joint density should be equal to product of marginals. So even there also in discrete we have had the same condition. Joint PMF must be equal to the product of marginal PMFs. Here also the same thing. Okay. Same condition you have to check. And also the conditional density is also same. If I have A such that my fx of A is greater than 0. So if my density is greater than 0, then fy given x is equals to A of y. So the conditional density of y given x is equals to A can be equated to fxy of A comma y divided by fx of A. So the same similar thing which we had in discrete case also, the conditional PMF. It's joint PMF divided by marginal PMF. Here also the joint density divided by marginal density will give us the conditional density. Okay, nothing new. This thing. So just try to solve this problem and that's it. We are done with week 5 and 6. So the same thing, we know the K is equals to 6, previous example only. But what I want is, I want the marginals first. Firstly, I want the marginals. And then I want are x and y are independent or not. Then finally, I have given some conditional density. Probability that x is greater than half given y is equals to 1/4.
Sir, Can you just look at one of the graded assignment questions from week 6? Because that is asking to calculate a set probability at a line.
Okay, I will just take a look at it. But before we will solve this and then we will go there.
Okay, sir.
So how do we do first of all? So firstly, we have to find the marginals first. So for calculating marginal density of x, I have to integrate y, unwanted y, along the support 0 to 1, 6x square y dy. So this is 0. So if I integrate now, x square is constant now. So I have to integrate y. So 3x square y square, limits are 1 and 0. So you just have to integrate y. So this will be 3x square. And similarly, you can compute fy of y. So I have to integrate 0, 1, 6x square y dx. So unwanted is x. So if I integrate it, so 2y x cube, limits are 1 and 0. 2y. It is 2y.
Yes, sir.
So now I have the joint is actually equals to 6x square y, and my product of marginals is equals to fx of x is 3x square into 2y, which is 6x square y. So both are equal. So joint density is equals to product of marginals, product of marginal densities. So what can I say?
They are independent and
They are independent.
X and y are independent. So this is how you check. So in order to check for two continuous random variables independence, you have to compute the marginal densities and you just look at the product of their marginals. If that is equal to the joint, then they are independent. So okay, are they independent? Yes. And have we found this? Yes. So now we have to find probability that x is greater than half given y is equals to 1. So this is nothing but f x integral half to 1. So as x is greater than half, I have to integrate it till 1. F x given y is equals to 4 of x dx. Okay. So now you see. So this is what it is, right? So I have to integrate all the x's from half to till 1 and on condition. So this is actually, I can write it as f x comma 4 xy joint divided by marginal. And this is dx. And this joint is basically half to 1. fxy of x comma 4 will be 6x square into 4 divided by fy of 4. So the marginal fy of 4 will be 2 times 4, which is 8.
Sir, we did this 6x square into 4 because it is independent, right?
6x square. No. See, fxy of x comma. So fxy of x comma y, I know that it is equals to 6x square y.
Yes.
So this y, I know that it is equals to 4 now. Just substitute 4 in place of 5.
Oh, okay.
So if you simplify this 4, 2, 2, 3. So I have to integrate half to 1, 3x square dx. It will give me x cube.
But we can also do that also.
That also, because they are independent.
Because it is independent, yeah.
So they are independent. So
then we will also get 3x square.
You can directly write fxx times fy4.
Yeah.
and this will get cancelled.
Dx
It is
square.
actually fxx. That is what we got, 3x square.
Dx square.
So if I integrate it, I am going to get 1 minus 1 by 8, which is 7 by 8.
But sir, sir, in case of one continuous, one discrete, we have another meaning of conditional validity.
No, okay. In that also, it's not that important, but also okay. Anyway, you just pointed it out. Even that case also, we follow the same conditional is equals to the joint divided by marginal, right?
Okay. Joint divided. Okay.
But the joint, we write it in different way. The joint, again, we will write it in product of PMF into conditional.
Yes, sir. That's
okay. Yeah, that's it. See, joint is again, see, this is interrelated. Okay, joint, marginal, and conditional. So joint is actually equal to marginal into conditional. So from there you can push anything.
Sir, this probability of x greater than 1 by 2, this question only, sir. This probability of x greater than 1 by 2 when y equal to 4 is not equal to probability x greater than 1 by 2 and y equal to 4 divided by probability of y equal to 4.
Is not equal to
probability of x greater than 1 by 2 comma y equal to 4 divided by probability of y equal to 4. This is not right. This is not okay to write.
See, probability that y is equals to 4 is not right. So we will talk about densities. That is why. See, probability that y is equals to 4 is 0, right?
Yes, sir.
Correct?
Yes, sir.
Y is continuous. So that is what slightly there will be small changes in density and that discreteness. See, that is why I say when we talk about continuous things, always remember that 0 we treat it because it is very, very less quantity. That is why we treat it 0. Okay, always there will be some dx. There will be some small width dx which is invisible to us.
Okay.
So always keep that in. Okay, so that's it about week 5 and 6. So those who wanted to just take a break, I am done. You can leave.
Oh, sir.
And even
that expectation thing that we were discussing about, no? Maybe that we can discuss that.
Okay. So the other people, do you have any doubts? You can ask. Just prepare again week 5 and 6 and then just try to give the mock 5 and 6.
Sir. Sir, I have a small doubt in joint density of uniform. Why joint density of uniform distribution is equal to 1 by area? Sir, 1 by area, I am not understanding still now.
Okay, can you do one thing? Can you just go to week 6 activity/practice, which I have taken it. There we have discussed regarding this. Why is that is 1 by area? I have proved it.
Okay.
Okay. So week
Hello,
6
sir.
activity and practice. Okay. First session. Week 6 first session.
Okay.
Hello, sir. So I have asked regarding the uniform distribution. No, extra activity 5.
So what is that?
Sir, actually, in general, first thing, see, when we have that kind of discrete data and when we want to convert it to function, how do we actually do it, sir? Like,
when you have to
we
convert?
see, we have got a data, say, for example, for this extra activity 5, I have taken a marathon race and a player how over a period of 5 to 10 years, how much, I mean, what is the time taken by a player to complete the marathon race. Okay, and so when I try to plot it, actually I got it similar to the uniform distribution. That is, the time taken by the player over a period of time is almost same. Like 2 hours, 5 minutes. So like that, it's almost similar. So it came to uniform distribution, and so I have plotted. My query is that when I try to plot in a graph, like in the histogram or the line graph, say for example, I took from 2015 to 2020, so 5 years. Uh, what I mean, the time taken by that player I've taken. So 2015, I mean, when look at when I calculated the CDF, actually 2015 it came to some value, and then in 2016 it came as 0, then in 2017 it came with some other values, then again 2018 it came as 1. Now my query is, if we get like not like a continuous, like from 0 to 1, when I'm telling, when I calculated CDF using the formula like 1 by sigma into square root of 2 pi, no, that
that is for normal.
Yeah, that is normal. But when I try to initially I tried to work out with normal, it was not working out. Then I went for uniform distribution. Like as you said, 1 by b minus, I use that formula. But my query is, when I try to map the CDF in the graph, no, it came with different values. Like as first it came some value, then 0, then some other value, and again 1. So if we get like I mean, it's not orderly from 0 to 1.
That is
Is
not
it okay to plot
CDF.
that way?
No.
Sorry?
See, CDF will always be a non-decreasing function. So maybe you are
non-decreasing.
Maybe you are missing something. That's something I will.
So actually, sir, when we are trying to do like this extra activity kind of a thing, do the instructors actually validate it, sir? We know peers are reviewing it, but we don't. I don't think honestly we are getting the feedback. Like even they themselves don't know whether they are able to validate what we are doing is right or wrong. So do the instructors actually validate what the work we are doing is right or wrong? So where do we go and get help from? That I'm not able to understand actually.
I understand. We do have some 2 TAs with us, so they will be going through each one of your activities.
But we don't know what we work out is really correct way of whatever you are teaching now with respect to function, with respect to theory, but when it comes to actual data, we haven't seen any examples with respect to actual Excel data kind of a thing. We are working out on by ourselves. So is there a way to validate what we are working out is right or wrong, where to get help from? So can you just help me out, sir, how to?
Okay, I understand. For this, we can see sometimes in sessions or whatever the 2 hours time we have. See, even today's session also, it went till 3.5 hours, right?
No, I understand that, sir. Are we? I am asking. See, in discourse also we are just mailing, but we can't explain all this in discourse like each and every point, like because it is an Excel, it has huge amount of data, and so I'm asking you: is there any way going forward to validate what the work we have done is? Because I don't know, even peers could be able to understand what the work we have done is right or wrong. Even if they are also learners. So I'm asking, is there a way to validate the work what we have done is right or wrong, or somebody to guide us that it shouldn't be this way, it should have been done this way, like that? Because we are doing some work, but I am not confident enough whether what I have done is right or wrong. So as now I told CDF, it came first at some point, then it came to 0, then it came to some other point, then it came to 1, then it came to some other point. So I don't know whether the work what I'm doing is right or wrong. So that's why, sir.
Okay. What we can do is we can have few other sessions where we actually deal with this extra activity or something.
Because we don't usually deal with data, no, during the live sessions. It's only theoretical, and that's why I asked: is there a way? I mean, how do we know that in an Excel sheet we know, say for example, if it is a age, it's going to be variable, but how do we see that in point of function? Say for example, we derive a function as kx. Now you told the function is kx square y. So like that, how do we manipulate into function, and is we always deal with only numerical data when it comes to Excel, but how do we convert into function and how do we integrate? So I'm asking in a practical terms where actually we'll be able to correlate the data and the functions and work it out. So that
Right,
way
right.
it's very difficult to understand and work out when it comes to extra activities.
I completely agree with you, but see, this is just the foundation level, right? Whatever you said, you are
Okay.
going to see it in the later courses. Okay, you will deal with
Later courses in the sense in the later weeks, sir.
later, like no, not in the later weeks. This is just the statistics 2 course. Okay, so you in
Yes,
this
sir.
particular course, you will get to know how the data are. So if a data is given to be following this, how I can compute? So you will do the later part of it, not the first part. So there are 2 parts, right? Firstly, you should build the model, then you will compute and predict the future.
Yes,
Correct?
sir.
The
Yes,
building
sir.
model, as of now, what we teach you is the building model is predefinedly given to you,
Yes,
and you
sir.
have to do the later part like computation and predicting
Yes, sir.
future probabilities and everything. What we give you is in this statistics too. Okay.
Yes, sir.
Later in machine learning techniques, you will try to build models even in
Yes, sir. I am
I
part
don't
of MLF actually, Machine Learning
uh-huh.
Foundation. There we
Machine
have a
learning
model, but there
foundations
also
is
we have the inbuilt models
uh-huh.
given,
right.
and we just validate whether it is a valid model or not. My query
Hmm.
is with the numerical data, how do we convert that into model first of all? So that
See,
where will we be looking in
will
this
it
course or later?
no later only, maybe in ML practices, I guess. ML practices you will
Okay.
see, these things will come in future also, in future,
Okay.
not now. Okay.
Okay. So
So
because I try to, use with different distribution. It's like we are doing with something in mind, but we are yeah, I mean, I don't know about others. From my side, it's like I'm not completely sure what I'm doing is right or wrong, and that distribution what we conclude is the right or wrong. So that way I'm when we say uniform, I mean normal distribution, the curve doesn't come properly to bell shaped. So can we still conclude that as normal distribution or not? So that's that kind of doubts we have.
see, I
So
understand. See, any
mm,
distribution can be fit into normal, okay, but with some error. Always there will be
okay,
error and bias. Everything will come into the picture.
okay,
Okay.
sir,
So
okay,
without error, no data will fit into a perfect model. Okay.
okay,
That is for sure. So
okay, sir,
fitting the data into different distributions will give you different errors. That's it. So if you fit this particular data into
okay,
uniform, your error might be large. If you try to
but
fit with better fit,
okay.
this is called better fit, right? Good fit or better fit. So
I
we
asked the
won't
same
hope.
question to ma'am also last time. Actually, based on the data, how do we determine that this is going to be this type of distribution? We work it out, we formulate and all. But still, when I mean, when it is not even coming to a proper shape, still, how do we define? How do we come to a conclusion of that this falls into this distribution, sir? Is there a way?
Also one more thing. These are just common distributions. Okay, in real life, not
Okay.
even majority of the data will not fall in any of the well-known distributions. That will follow
Okay, sir.
something else. Okay.
Okay.
But what we do is we actually look it in the outer way and we try to fit it. We try to whatever we know that only we can do, right?
That's what I'm
We know,
asking, sir. What we do is right or wrong. Somebody should, I mean, that is the
that
instructor
validation
or
thing. I understand that validation thing.
uh,
We will try to arrange few sessions. Maybe that is as of now I can say. If there is a
okay, sir. Because
method, you can suggest us.
no, I don't. I'm asking because are you all following? Because we are doing this extra activities. We are doing peer review. So do instructors also? Because when I posted first, when I did the extra activity one, my link. was not working, so they gave very less marks. So then I posted in, it was a system error actually. I have posted 2 links. System took as the complete both the links as the one single link, and everybody were telling it was not working. But system doesn't take the enter key, and it took everything as a one single URL, and it just said it was not working. So I posted in Discord, and I got a reply telling that we will review it and we will give you the marks. So like that I got replied. So that's why I'm asking.
Okay, the answer for your
Sorry, I'm
question is
getting
yes.
loud.
Yes, yes.
Sir?
The answer to your question is yes. We do review few extra activities, not few.
Okay.
Our
Okay.
TS will review all the extra activities done by the students.
Okay. That
But if they,
validation part also, will they do and give the comments, sir? Like,
see, no, not the comments. If they feel the peer reviews, whatever the peer reviews have given the score, if they feel it is okay, they will not do anything. If the thing is actually good, and if peers have given very less marks,
okay,
then
sir.
these kind of things they will bring to us, and we will take a look at it.
Okay, sir. So that's what I want to know. Like the work what we do is right or wrong. We are not confident enough. So is there a way to?
They will look at it. They will look at each and every one's, and they will
Okay.
validate themselves. They will also validate, and if it matches peer, they won't do anything. And if they feel it is something, things need to be changed. Sometimes it might happen like this also. Peers will give some 190 like that.
Yes,
But
yes,
he
sir.
might not do anything. They will be like decreasing him for 5 or 10 marks. Like
I understand, sir.
so we will discuss those, but yeah.
Okay, so maybe you can just discuss with other instruction, and you can tell us the way. No, it's a learning phase because we are trying to learn whether, I mean, how much we have gained, the knowledge we have gained is really working out in the real life scenario. That's all, sir.
Completely agree. See, we do always accept feedbacks. Okay, it's not like always we should give some suggestions. If you have ideas, you can also suggest us. You can do like this. You can do like that.
I know that.
Okay.
I think, as you said, we can have at least weekly 1 hour session for extra activities, and maybe we can pick up any one student's data random. Maybe after instructors reviewing it, you can pick up the very good one, and we can discuss. But I think already timing is
pretty hectic.
No, it's like contradicting with other classes like stats, MLF, BDM, and all. But correct. I think maybe weekly one class. At least we can have to discuss, the better, I mean, whoever has done best, or maybe after instructors have reviewed it, if you feel that they have done really good work, you can show us and explain how they have done. So we'll also, learn like how to see in a different point of view, because that's what, as I said, like what we do is right or wrong, we ourselves are not sure. So that is the main problem, sir. Like, we are working out, so
sure, completely agree.
We are just getting the comments, but not validation. That is what I am asking.
Sure.
Okay, sir. Thank you.
Can we discuss that expectation thing?
Smile. Okay. Yeah. Just give me 2 minutes, okay? I will just come back. I will just stop this recording also. It's already 3.5 hours more. I'll just have a sip of water and I'll just.